And we're going to talk you through a variety of really interesting things about what you need to know about getting started with databases.
Thanks, folks, for joining us. I am, as Pete pointed out, Brian Alderman. I live in Scottsdale, Arizona. Really enjoy that area. We are going to be spending some time, as he's talked about as well, talking about the database fundamentals. Not too deep on what we're going to be discussing, but just kind of give you an idea of what databases are all about. I'm a speaker for a lot of conferences, specifically with SharePoint at this particular time, and some SQL conferences as well. So we're going to be spending some time. You're going to see some when we get in the image, some references to SharePoint. So, but it's this topic is all about SQL Server and the understanding of that. Now, Pete, what about you? Where are you from?
So I'm here. I work for Microsoft, and I work for the learning experiences team here. I'm responsible for planning and building a lot of the technical training content that guys like you, trainers like you, deliver to Microsoft customers. So I have a hand in some of the technical content here. I've been doing it for a very long time with content, and I'm responsible for the SQL Server portfolio in addition to some of the web developer content that we have.
Awesome.
So this session is a 100-level session, and database fundamentals is a sort of core technology concept that this session loosely maps to our Microsoft Technology Associate exam for database fundamentals, which is exam 98-364. So if you're looking to get started in databases, there's no prerequisite level required for this.
Don't you have to learn, be able to spell SQL?
You have to be able to, I don't even think you have to spell SQL. I think you're going to teach us how to spell SQL a little bit later in the session.
That's the primary goal, is to understand how to spell SQL.
I think the only real expectation we have for this audience is that they want to learn what a database is.
Very good.
And we'll go from there.
All right. What are we going to talk about today?
So the course is broken down into 5 modules. The first one that we're going to do right now is just introducing core concepts. We're going to help you understand what a database is, why you might want to actually consider getting a database. We're going to go from there into some of the basic concepts that make up a database. We're going to talk about relational concepts, including normalization, referential integrity, and some other topics there. We're going to go from there into how you actually create and use them, what kinds of things are in a database. We're going to talk a little bit about SQL Server and how that works. That's going to be the platform that we use when we get into creating our database. Module 4 is going to be really super fun. We're going to talk about DML, which is data manipulation language. We're going to actually show you how you can get data in and out of the database, which is probably the most exciting stuff. I know you've got like all kinds of really fireworks-enabled demos for that one.
Great demos for that.
And then Module 5, we're going to talk a little bit about SQL Server specifics. We're going to talk about basic administration concepts that maybe you'll do as an administrator, or maybe you'll want to know about so that you can have a good conversation with your database administrator.
All right, so let's dig in with the very first module where we're going to talk about the core concepts or with databases. And the ironic thing is a lot of people hear the word database and they don't understand how much or it's involved in their life. For instance, if you go shopping, if you go to the store this afternoon and buy some items off a grocery store, way back in the old days, you would probably go into a grocery store and there'd be aisles blocked off because they're taking an inventory of what's on the shelves, what's in the stock room, so they would know what to order. Nowadays, everything, because when we pick up an item off the shelf and as soon as that we scan it, that's being registered in a database. So now they can set up and keep track of all of the items that are stored within a store in a database. And anytime I purchase anything, that item count, let's say we have 50 of them, now went down to 49. We can set up an alert in the database, hey, if this gets below 25, we need to reorder. So everything is automated. If you go online and buy airline tickets, that's all information stored in the database. When you get ready to pick your seats, that's all in the database. So every day, even though we don't hear the term database, we are talking and working with databases. So that's why this is important for you to understand that, you know, the concepts of a database and what's going on behind the scenes, because it does affect you as a non-IT person, but it may be something that you want to get into as an IT person because there is a lot of need for database administrators or DBAs. So, wrong way, we'll go back this way here. So we'll talk about relational databases, and we're going to talk about some database components and terms, kind of level the playing field, so everyone has an idea when we're referring to something, what it is that we're referring to. Then we're going to talk about a few different types of commands that we'll use when we're talking with and working with SQL Server. So let's begin with an introduction to a database, just to give you a better understanding of what the databases are all about. A database, you might just see it as a DB, is an organized collection of data, and it's typically stored in electronic format. It's really not much different than what we've done in the past, but we had a different way to do it. It allows us to manage content, organize content, or categorize it, and more importantly, allows us to retrieve that content fairly quickly. Traditional databases are stored in rows or records, and then we have columns or attributes or properties. You'll hear those terms synonymously as it's referring to the type or the amount of content or the information that's stored in a database. Now you may be thinking, it's like, well, Brian, that sounds a lot like one of these, good old Excel spreadsheet. And it is very similar to an spreadsheet in the fact that we have rows and we have columns, and we've used these for several things. Now, Pete, can you remember the first time you used an Excel spreadsheet and you thought it was the coolest thing because you could have rows of information and then columns of that information that was relevant to those rows?
You know, it's funny. I actually still use one of these today, which I'm a little bit embarrassed about. But I use a spreadsheet that's got all kinds of columns to manage my music collection, my CDs.
Okay.
Right? And I've got a row for every CD in my library, and then I have all of these columns, and I've added so many columns for the person who introduced me to it, and the genre of the music, and the date that I acquired it, sort of like the High Fidelity movie, like if you want to sort the thing by the date that you acquired it, so you can look at your library in chronological order, I do that, right?
So
I don't
want to interrupt, but just to let you know, I have the same exact thing for both my CDs and my DVDs. So, I mean, I still have 300 some odd CDs, and they're all alphabetized. And so I'm not the only weird person. This is really good to know.
And it's funny, too. I'm actually going to probably use this example throughout the course because it's the perfect thing that could make a really handy small database. And even though I've been working with databases for 20-something years, I've never actually converted it to a database.
But we could take that content and convert it into a database and put it in a table. This is an example, just a brief example of a database table. And that's, as I mentioned, it's a collection of rows and columns that allows us to organize content. We're going to focus on relational databases. This brings it to an entirely different level. Pretty much if I took this table here, I may as well put this into a spreadsheet, because at this point we haven't introduced the idea of creating multiple tables to represent this information, which makes it, and we tie relationships in those. We're going to talk about all this into these different tables, so we can actually use this content for querying information and inserting information, updating information, and keeping this information maintained. So we're going to take an Excel spreadsheet and we're going to jazz it up by bringing it into tables or multiple tables in a database here. So relational databases, it's a collection of tables. Now, instead of everything stored with 80 columns across in a single row, we're going to have maybe fewer columns, but we're going to have multiple tables. Now, the relational piece comes into the sense that we have to have a way for us to be able to have those tables talk to each other. So we're going to introduce the concept of primary keys and referential integrity and foreign keys, and we'll figure out how all that is, how all that works for us. But the idea now is taking that single row or single table as multiple columns, 80 columns we'll say, and busting that out into multiple tables to create an environment that allows us to query that information and only store the information that we need to store and not have redundant information stored in that. So that's the advantage of moving to a relational database from, we'll say, an Excel spreadsheet. This is an example of a relational structure we're going to be referencing throughout here. And what this allows us to do is, you'll see here that we have a table here called products, or in the production schema, and we've got a product subcategory ID. Now this is referring to another table, and it's a product subcategory ID, which in that table there's a product category ID, which is referring to yet another table. So this is what's called relational databases, and we're going to introduce these terms and discuss these in more detail, but this uses what are called primary keys and foreign keys. And so this here is a way for us to tie these tables together so our tables can communicate, and it's going to allow us to perform some of the commands that we're going to want to perform, and we'll see us performing a little bit later on.
So that actually looks a lot like what we were just talking about, where my spreadsheet full of CDs,
Yeah.
in this example, would be the products.
Yeah,
And
exactly.
the genres in my spreadsheet would sort of map to what you've got here for category.
Yeah, perfect.
Or subcategory, category, like, because I have jazz and I have like bebop as a subcategory of jazz and things like that. Is that kind of what you're
Do you
talking
have
about here?
disco, and is disco in there?
Disco is not a
Not- okay.
subcategory of jazz.
Okay.
but-
Subcategory jazz. Jazz, disco, jazz. Yeah, I can't even picture that one happening. But yeah, it's exactly a great point. Yeah, so we could take our example of our CDs that we have built into a spreadsheet, and we could create a database and use a similar approach to get this a relational database with these tables. So great example here. Okay, let's make sure everyone understands. And we're going to, as we go through these sessions, we want to make sure everyone understands some of the terms that we're going to be using as we're coming down through this. First off, you may have heard of a DBMS, a database management system. So we're going to introduce a couple products like Microsoft SQL Server, was what we're going to be focusing on and using as our demonstrations. But a DBMS is a database management system that it's several programs that are used that allows the data for us to store the data and retrieve that data. So a DBMS is also used for DBAs, database administrators, and this allows them to be able to go ahead and manage the databases, to create the databases, to add the databases, to back up the databases. Any of those components that we would need, it allows us to do that using the DBMS. So it's a collection of applications that allow us to not only look at the content, manage the content within the tables, but also the overall administrative tasks. Those also are managed using this DBMS. Now we can throw another letter in the front of that with a little bit of alphabet soup here. We have an RDBMS, a relational database management system. An RDBMS takes advantage of the database management system, and we make sure that we're taking advantage of the relational aspect when we're managing that content. So as I mentioned, Microsoft SQL Server is an example of an RDBMS. Microsoft Access, if you've worked with that, maybe you went from Excel spreadsheet and you graduated to Access, and then the next tier would be going to Microsoft SQL Server. Even using MySQL, if you're out there using MySQL, you have those for relational databases. And those are ways for us to manage our content instead of the flat format that we're used to using with our Excel spreadsheets. Now, in order for us to be able to install or use this content, we have to have what's called a database server, a server that's dedicated to hosting our content. Now, it could be a physical server, it could be a virtual server, but it's used to manage that content, but from creating the databases to the content that's stored in those databases. This database server can have multiple instances. What does that mean? I can install SQL Server several times and manage them separately. We have the same tools that we use for managing all those instances, but I can install SQL Server several times. One may be hosting my SharePoint content. Another instance of maybe hosting my line of business applications. And I can install that multiple times on a single server, and that is what the idea of an instance is. It's just multiple installations that reside on a single server. Every time I do that installation, there's a new copy or version of the SQL Server.exe that's used for managing that content. So often what we'll do is create multiple database servers, and the idea of this is for us to provide high availability and improve performance. If we have multiple servers, we are able to do that.
So let me just back up for 1 second.
Sure.
Because I have my spreadsheet full of CDs.
Right.
And now you've gone all the way to the extreme end of things. You were practically at big data, which we're not going to talk about today. But there's this whole range of things that I can do to get my first database that start with something as simple as Access, which is a part of Microsoft Office, where I can install it on my local machine. I can even export my spreadsheet or import my spreadsheet into a database and start making the relational sort of connections that you've alluded to, these key things. All the way up to a database server that's dedicated for a professional environment, an enterprise application that runs an instance of SQL Server or multiple instances of SQL Server. So I just wanted to kind of point out that there's this range that you're talking about from getting from non-relational data that's in a spreadsheet all the way to massive multi-table relational systems on multiple servers and clusters and all that other stuff.
Yeah.
And for the scope of this conversation, we're going to talk really straightforward about the fundamentals of what's in a database. But Brian's made a really good point that we're at the very beginning of a long journey to using databases that go all the way up to professional database administration, database developers, business intelligence, and now big data, and even databases in the cloud. So there's this spectrum that we're talking about across all of these sort of terms. And the rest of the session is going to be kind of on a smaller scale.
Yes.
But will allude to these sort of different opportunities that you have across different business solutions and in my case, my CD library management system.
I'm expecting, knowing you as much as I know you now, that's going to probably be done by the end of the weekend. I'll expect to see how your tables tie out, because then I'll borrow.
I'm going to design it
I'll borrow
right here.
Your database design, definitely. All right, so yeah, we are going to keep it on a small scale as far as what we're going to discuss, but as you know, we pointed out, this could be to the enterprise level, but we are not going to go to that level in here. What we are going to introduce is, because remember, we could use Access, we could use MySQL, we could use a SQL Server, Microsoft SQL Server. So what we're going to do is we're going to work with a utility inside of this that's provided with SQL Server called the SQL Server Management Studio. So the good thing is you don't need to know a bunch of commands. There's a lot that we can do inside of SQL Server, inside specifically of the SQL Server Management Studio. And this is just a screenshot of it. What we're going to do is we're going to go in and demo this and kind of just explore what we can do in this graphical user interface, or GUI, to manage databases, manage the implementation of the databases, and even down to the table level of the content in the databases. So let's jump out and explore. We're going to go into a demo here, and let's go into our Contoso database. If you've gone to any Microsoft class, you've heard the term Contoso. We are going to go into, I'm going to go to Start and All Programs, and in here you're going to see that I've got Microsoft SQL Server 2012. You'll see I've got SharePoint installed. I'm going to go ahead and expand on that. You'll see we have several tools we can use in here. We have configuration tools. If I expand on that, that's where we can use for some configuration options. The one we're most concerned with, the one we're going to spend the rest of today in, is the SQL Server Management Studio. So we're going to open this up, and when it comes up, it asks us to connect to the server. So we'll go ahead and perform that connection. And it brings us in to the left-hand side, we have what's called the Object Explorer. And the right-hand side, we have the Object Explorer details. So whatever we click on the left-hand side, it gives us more detail about it on the right-hand side. Let's start, first off, I talked about instances. This is an instance of SQL Server that's running here at the top level. I don't have multiple instances. If I had, I could use the same tool for managing multiple installations of SQL Server. We're going to focus on just one instance here. Now in there, the next big thing that we work with are databases. So if we expand databases, you're going to see I've got several different databases here already, including system databases that are automatically installed for every instance of SQL Server. So if we expand on that, you're going to see we have these 4 system databases. We're not going to get into the detail of those, but every instance of SQL Server has these 4 databases that are used to manage the infrastructure and the logical architecture associated with that instance of SQL Server. Now we also now have user databases. The rest of these, besides the system databases, with the exception of database snapshots, all of these here are user databases, or databases that we've created. We're going to be focusing on utilizing, for the most part in this session, or in these sessions for this class, the AdventureWorks 2012 database. If you've worked with a database before, see previous versions of this by any chance, you've probably heard the term AdventureWorks. So there's a flavor of it that you can use. Now, if you're seeing our demos, you're like, hey, I'd really like to explore with this, you can actually go up and download AdventureWorks 2012 and install it in your AdventureWorks 2012. If you're running SQL Server 2008, you can install it for that as well. So if you're looking at this, like, this would be pretty cool to be able to have this play environment, you can do so. Just explore, look for AdventureWorks, and download the flavor for your particular version of SQL Server that you're running, and you can be able to use that information.
And I think it's also important to point out that what you just showed very briefly in the initial view of SQL Server Management Studio, it showed that there were some objects, and I know we're going to talk about that later. But every database system, even Microsoft Access, has something similar. You can open Microsoft Access, you can look at the databases that are there. In that case, you'll see one at a time, but you can see the things that are in that database. And there are sample databases for Microsoft Access, just like there's AdventureWorks for Microsoft SQL Server. So if you wanted to try this as you're following along, you could load up Microsoft Access. You can find, I don't remember what samples ship with Access these days.
Northwind?
Is it still Northwind? Northwind is shipped forever. I'm not sure if it's still there or
I
not.
haven't opened up Access in a little while. So.
Yeah, but there are sample databases and there's open source databases, and you can see what sort of you can explore the relationships and products and categories and things like that are a pretty common thing that you'll find in all of these samples.
Yeah, that's a great point. So we're going to be working on SQL Server Management Studio as our GUI, our graphical user interface for SQL Server. But that's a great point, Pete. I mean, it's like, okay, well, I'm used to sort of a spreadsheet right now. What's my next baby step? My next baby step would be maybe I try Access next. Get the idea of how that works, how the relationships work between the tables, and then go up to upgrade to the SQL Server environment. And there is a SQL Server Express flavor available too. So you may like, hey, I'm done with Access. I really want to go out and play with SQL Server. There's a SQL Server Express version that you can download. It's free, so you can download that and get most of the functionality that you'll see that we're working with, even though we're working with the enterprise version. For what we're going to do in this class here, that Express version will work for you. Okay, so over on the left-hand side, we've got this here. What we're going to be doing a lot of here as well is generating or creating queries. So up here, I can go in and execute queries in here. So I can do a simple query. This is the most basic query you can execute. And look at the IntelliSense. So it's helping me along with this. So if you're not quite sure, it's helping me along. So production dot and then products. Hopefully I did that right. We'll find out. Invalid object name. So I can hover over it. So it's all right. So I'm not sure. So we come over to the left-hand side. We go to our AdventureWorks. We go into our tables here. And you're going to see all the tables. Now, all of these tables, starting with human resources, all the way down here, are all used for this AdventureWorks table, or database, excuse me. So I was trying to use production.
I think you're in master.
And here's my products. And so it is an actual, I have an X on there. And so I'm going to go ahead and then I'm going to hover over it again. And you're going to see it's still saying invalid product name. Now there's two ways. What I haven't done is I haven't identified what database I want to use. So there, if I look up over here, right now it's using the master database. When I connect, it automatically connects me to the master database. That's one of the system databases. I don't want to work with that one. So I can do this a couple ways. I can come in here and drop this down and find my AdventureWorks. Now when I hover over this, you're going to see, oh, now we got what the item that you're working with. Now if you like to make sure you know what you're doing, another way to do this is to preface this with the use statement. And so I could do this as well. Instead of having to drop this down, especially if I'm going to want to write as much of this up as possible, I could make that part of the command and add in the text, use AdventureWorks 2012. So we're telling it what database we want to look at. Now I want to perform this command here. So we're going to go ahead and highlight this. And this is kind of cool because if I have several statements in there and I want to execute just one of those statements, I can do so by highlighting the text that I want to execute and then hit the execute button or hit the F5 key. So we'll hit execute up here and we get a bunch of data. So here's all my rows of content with the columns. And like I said, this is the most basic, the easiest syntax that you can write is select asterisk, which means give me all the columns from wherever I want to retrieve the content from. So we'll be spending some time in here. Again, I wanted to kind of show you that this is the Object Explorer, and we have the details that are going to be showing up here. We're going to spend most of the time in the new query window executing queries that allow us to retrieve or insert or update content. But this is just a little bit of an introduction.
That's a sneak preview of Module 4.
So it's a sneak preview of Module 4. We're going to do a ton more in here. In fact, I'm probably going to resize this so you can see some of the commands here that we'll be working with. But you're going to see for this database here, AdventureWorks, we have tables. We're going to introduce these views, synonyms. The fact I said that right the first time is good. I spoke too quick. Programmability. storage and security. So all of these are per database. We're going to talk a little bit later on in security, so we'll get that a little bit more information and detail with that. All right. Anything else we should show while we're in here, just as an intro? Do you think of, Pete?
You know, I had a question for you if you wanted to go back to that. You've said a couple of things that I think we should clarify.
Okay.
You used the word schema. Can you talk just briefly about what you meant by schema?
So really what happens is when you create a table or a view, it has to be associated with an owner of that. So they're using the word owner or schema is where it resides and who has access to that and how that is stored in that database. So the schema or the owner of that item is used. This is a two-part name. So you actually provide the schema and the object name. You can actually go up to up to 4 parts. We won't get into again here yet. Actually, we won't get into in this specific class. So it just identifies where inside that database that content or that object exists.
So it sort of references kind of the definition of what that object is.
Yeah, exactly.
Yeah. Okay, got it.
Right.
And then I think there's one other thing that we should talk about because we're not talking about it.
Okay.
In my example of the spreadsheet, we talked about that I have all of these rows and all of these columns, and it's getting kind of unwieldy to manage. And you've introduced this concept of a relational database that has tables that have used rows and columns that relate to records and properties. And that whole genre of sort of information, we kind of refer to that as data modeling.
Yeah.
Right? And we're actually not covering data modeling in this session, but it's a really important topic that you guys will want to go read more about, that is sort of the technique for how you decide what to do with that giant spreadsheet of information and break it down into the individual parts. And we're going to reference that sort of thing along the way, but I just want to point out that how you actually do data modeling and how you do the design of a relational database is not specifically covered in this session.
Yeah, and you're right, there's entire courses on that, and there's a lot to that piece. That database design is huge before you even roll out any data. So taking that very seriously and understanding what you're doing there will be really beneficial for you as you're looking at taking your ginormous spreadsheet and trying to get it into a relational database.
And we'll allude to some of those things as we go along, but I just wanted to call out that we're going to talk kind of about the mechanics of what a database is and how the pieces of it work, but the next thing you'll want to do when you actually create it is you'll need to understand that data and then do that sort of analysis and design of what the data model needs to be. So we'll see some of that along the way. I just wanted to point out that's an opportunity for further study.
Yeah, perfect. Yeah, and it's a very, very important part of the process here. All right, so I don't think there's anything else in here. We'll be coming back. We'll be spending a lot of time inside of these SSMS, SQL Server Management Studio here. So let me go back here. Oh, that's why I didn't want to do this right there. And let's jump back into our slides here. Whoop. Where'd I go here? And where we were in PowerPoint, aren't we? Yeah, we're using that guy. Okay, so that's just a brief introduction to the SQL Server Management Studio. We're just going to wrap up this module with just a little bit of a review. Remember, a database is kind of taking your ginormous Excel spreadsheet and just creating multiple tables and setting up relationships, all what we're going to talk about. But it's simply a different way to organize that content. It's not only different, it's going to be better. You're going to see that we can generate reports, we'll just say, or retrieve content, and slice and dice that content in ways that we could not do in an Excel spreadsheet. Microsoft SQL Server, Access, MySQL are all examples that we can use for that. We talked about the idea of a database management system, or a DBMS. So you're going to hear that term, a DBMS, or an RDBMS, which is a relational database management system. And really, it's just a plethora of applications that allow you to perform different tasks associated with that database. We talked about, right now we looked at the database engine. I mean, there's reporting services out there. There's analysis services out there. Nothing that we're going to get into, but an RDBMS has several components that allow you to manage that content that's in your database. Your database server or servers, most likely you're going to have multiple servers, whether it be virtual or physical, are used for hosting the content, managing the databases, and making sure we've got high availability, we've got information that readily available. So that's managed using our DBMS on multiple servers, database servers most likely. And then where we're going to spend most of our time is in the SQL Server Management Studio. That's the interface that we're going to use inside of SQL Server for creating our databases and managing the content within the databases, as well as managing content or managing the logical infrastructure, the rollout, the deployment of SQL Server. So with that said, we're going to wrap up on this section here, and we are going to go ahead and take a brief break here, and then we're going to come back and continue in Module 2.
Welcome back to Database Fundamentals. This is Module 2 of Database Fundamentals, and it is about relational concepts. In this module, we're going to talk about referential integrity and normalization, which is another big topic.
One, definitely.
That's right. And I think we're going to get into a couple of other small topics around constraints.
I think we should. We're probably going to introduce constraints at this point, so we have an idea as to how they'll help with the referential integrity piece of it. But
this is Module 2 of a 5-module course. If you've skipped Module 1, we talked about some of the core concepts about databases. And we'll be going on into other fireworks demos later on about how you create objects in your database and how you get information in and out of your database, and then a little bit about administration of your database. But now we're going to get into some of the relational concepts. So not quite data modeling yet, but we're going to talk about sort of the concepts that are the fundamental pieces you'd need to know before you can actually go and create a database.
Well, you brought up a good point in the previous session where we talked about the idea of data modeling. So this really focuses on that aspect of data modeling in the sense that, okay, I've got my ginormous Excel spreadsheet. You guys have got me convinced I want to move it into Access or SQL Server. How do I go about doing that? Well, how do I decide what do I take into consideration when I'm actually going to design that model that I'm going to use inside a SQL Server or Access? So what we're going to talk about here is what's called normalization, and we're going to look at what referential integrity and constraints, pretty much what we've already discussed here. So the idea of normalization is really it helps us decide how we're going to build our tables out for our content. What this does for us is it allows us to use a strategy that's been designed to determine what content is going to be stored where. So normalization is the process of organizing that data in a database within tables and establishing relationships between those tables. We hinted to that in the previous session. The process is used to also help eliminate redundant data. So if we go back to our DVDs, we had talked about that we have hundreds of DVDs, and if we have a genre of jazz, I might have that title in there 50 times, 500 times. It depends how many DVDs I have that are jazz related. So the idea of that is just kind of a little bit overwhelming. So if you look at a spreadsheet that's got thousands of rows and 30, 40, 50 columns across, if you look at it, you're going to look and see a lot of redundancy. And one of the things that helps with normalization, or normalization helps with, I should say, is the fact that we can eliminate that redundancy. By default, there's 5 normalization forms, as you can see here. One is eliminating repeating groups, all right? Eliminating redundant data is number 2. And the third level is eliminate columns that are not dependent on the key. We'll introduce what that means in just a little bit. 4 and 5 are isolated independent multiple relationships and semantically related multiple relationships. We're not going to drill into those at all. I just want to show you out there, if you look up normalization, you're going to see 5 levels. Most databases are designed to 3, and that's what we're going to focus on here.
So in the first module we talked about, we're not going to talk about data modeling. And now you're showing me that there are 5 normal forms of normalization, and we're going to talk about just the first couple of them. So this is another, this is a huge school of thought around what normalization means, and you go really, really academic. But we're going to keep it simple and talk about those first couple.
Yes.
But it's another opportunity for further study.
Yeah, this could be hours and a whole entire class.
I bet you could talk about normalization for like 3 days.
Exactly. All right. So first, normalization. How do we work with our content? The first normal form means the data is in an entity format, which means all of these conditions have been met. We've eliminated any repeating groups. And by the way, we have an example of this. So you're going to see this with Okay, it looks good in print and text, but what does this mean? Well, we're going to demonstrate this for you. Create a separate table for each set of related data. Boy, we talked about that with our CDs, how we're going to create a table that are, instead of having things stored in Excel, we're going to create a table for, for our artist and maybe for the genres and for the different types of tables. And then we need to kind of tie those together, and we're going to identify each set of data within the table. We're going to tie that using what's called a primary key, and we're going to introduce that as well. We're not going to use multiple fields in a single table to store similar data. That's pretty much what a spreadsheet does for us. We don't want to do that. We want to avoid that. So we're going to set up this relationships between the tables to allow us to create that. And we do this with, this is just introducing the first normal form. Our second normal form ensures each attribute or each column describes the entity. So again, if we go back to our CD, our CD is going to be, we're going to have a row for CDs. We want to make sure that every entity or every column in there is directly associated with that CD. So it's going to, and we're going to actually tie these tables together. We're going to be able to reference one table or CD table to our genre table by using what's called a foreign key. And again, I promise you we'll show you what that means here. Records should not depend on anything other than the primary key that's in that row or that table. And again, we'll expand on that. And we can create what are called composite keys. Composite keys, in order to make something unique, I may have to use multiple columns. So we could, and we'll explain that as well. So we could create what's called composite keys to make sure that we have the uniqueness in those rows. Third normal form checks for what are called transitive dependencies. They eliminate fields that do not depend on that key. So I might have extraneous information in there that's not relevant, and I want to put that in a separate table. So I may do that, and as part of the third normalization of the third normal form, when I'm massaging that data to make sure it's all in that third normal form, we're going to make sure there's no columns in there that aren't directly related to that CD. All right, and again, we'll show you that here. In general, if the contents of a group of fields apply to more than a single record, those require a separate table. So again, just conceptually, all right, Brian, you've got me convinced that we want to take our CDs and we want to put them take them out of a spreadsheet, put them in a database. How do I do that? So we're going to look at how we're going to address that using this third normal form. As I said, there's a couple other ones. There's a fourth normal form called, BCNF, so I don't have to try to pronounce the names. We're not even going to worry about those. There's a slight risk of not having the perfect design, but it shouldn't affect the functionality if we don't implement fourth and fifth normal forms. And that's why we're not even going to address those at this point here. All right, let's take out this table here. This table here is kind of like a spreadsheet at this point, but we've got unnormalized table. We've got a table here that has student number, to be more precise, advisor, the advisor's room number, where we can find that individual. And then for student 1022, they have a class 101-07, class number 2 is 143-01, 159-02. This is an unnormalized table at this point. So what we're going to do is over the next few slides, we're going to take that content and we're going to normalize that content. We're going to implement first normal form first, then second, and then third, and you'll see what we have for a result of that. Well, if you remember correctly, the first normal form, as it says here, is no repeating groups should be in that table. So notice what we've done here. We've taken class 1, 2, and 3, which is a repeating entity, and our group, and what we've done is that now we're going to have student. So now we have student 3 times. We have student 1022 with the same advisor, with the same advisor room, and the same class number. So you can see we got rid of the repeating groups, but now we've got some redundancy. We're going to address that in the next normal form, in the second normal form. So we've taken our unnormalized data and we've added some additional rows to it, and we've consolidated the number of columns that are in this table. All right, so we've taken that content and we now have no repeating groups because we've applied the first normal form process. Now, as we move into the second normal form, we're going to eliminate redundant data. So now what we've introduced, we've taken that one table and we've created 2 tables. The table now is called students. So for student 1022, his advisor or her advisor is Jones, and that advisor can be found in room 412. Student 4123 has a different advisor. She can be found in room 216. So that's a separate table. Now if we go to registrations, because we can't just drop the information about the registrations, we created a second table for the student number. Student number 1022 is going to be attending class 101-07, as well as 143-01, as well as 159-02. That's a pretty light load, don't you think? Only 3 classes? Come on, dude, don't be a slacker here. Anyway, and then student number 4123 also taking 3 classes. So we've taken the content, we've split them out now after first normal form. We've introduced a second table that's going to allow us to avoid or eliminate that redundant data. Let's take it to our next level, our third normal form. Eliminate data not dependent on the key. Let me go back just 1 second here. We're going to see here that in the student we have 1022, we have with the class number, but we have multiple rows, and you can see the students, that was under registration, excuse me. The students, we have student advisor and advisor's room. So if we go to our third normal form, we've got faculty, we've got student number 1022, their advisor is Jones. Now remember, if I go back, I'm going to flip back one more time. When I look at this, I've got student number, I've got Jones, and I've got the advisor's room is 412. Well, the main item, or the main column in here is student number. That advisor room is not directly associated with the student number, so it does not belong there if we're going to normalize our content. Hence, what we do here is we introduce a third table. Now we're going to have a student, my rows are off a little bit, we're going to have our student, which is 10022, their advisor is Jones. Now, I want to figure out where's Jones, where the room number is for Jones. I'm going to jump over to the table called faculty, and that faculty table is going to have the room number, and also we're going to include some additional information about Mr. Jones, and that's the department number that they belong to. All right. So again, no redundancy, and every table or every row in both these tables so far are directly associated with student number. So we've got student number, the direct association advisor. The advisor, the direct association is the room number and the department number. Now we go to our registrations table and we have student number 1022. That's going to be attending class 101-07. 1022 will also be attending 143-01, and as you can see, it rolls down that way. So we've applied the third normal form by looking at these because now we have our student number as one table, and it's mapping to the faculty table using this advisor name, and it's also mapping to a student table using the student name. So we've taken this spreadsheet or this unnormalized table, and then we've created 3 different tables out, and we've applied the third normal form, first normal form, second normal form, and third normal form to get that to what's called third normal form in the normalization process.
You may have just blown my mind a little bit. Can we go back
Oh,
a couple of slides and look at the original?
Right back here. So here's our original.
Right.
Yeah.
So I just want to just talk through that one more time.
Okay.
We've got student information, we've got the advisor information, we've got the advisor's room, and we've got the schedule for each student in one table. That's the unnormalized table on this slide.
Yes.
And you just kind of took us through the 3 levels of normalization, and we ended up with a student table, an advisor table. Can you go on to the next slide there?
And then, so we end up
a
with
registration table. Right, so the student, the faculty, and the registration. So we took that one unnormalized sort of spreadsheet-like table.
Yeah, exactly, yeah.
And you broke it up using these basic principles of normalization into 3 discrete entities of information. And just summarize that for me. So we went from one big table to 3 different ones. Why is that going to be valuable to me in my database?
Well, when we see it, so what now when we start retrieving this content, so first off, we're not going to have a bunch of, if we go back to our CDs, we're not going to have a bunch of jazz in there 100,000 times or 50 times. We're going to eliminate a lot of redundant data. So now, if I normalized an Excel spreadsheet at 1,000 rows and 80 columns and was able to normalize it in database tables, I'm going to have less data because it's going to be stored in there because I'm not going to have jazz in there 500 times. I'm going to have jazz in there once. It's going to be a one table one time, and I'm going to reference that table. Every time I have a CD in there, I'm going to reference that table and say, yeah, jazz associates to, general ID 123, and I'll reference that. So I'm actually creating a cleaner environment, less redundant data, and all my columns that are associated or within a table, the new tables, are all relevant to each other. They're all associated with that primary column. We're going to talk about that, what that means in just a few moments. We've already introduced the term, the primary key, and we're going to actually roll that out and show you how we do that in just a few moments here. So we've kind of cleaned it up. We've got more tables, so you think, wow, I went from one table to 3, but now when I get ready to retrieve it, when you get module 4, and I want to be able to slice and dice this information, it's going to be so much easier for us to do so than what we could do in an unnormalized data table.
Thanks. Yeah, that looks really good.
Great, thanks. All right, referential integrity. So this process that we just talked about too. So let's just review a little bit on the normalization. If you're thinking about where do I start, you can use the third normal form, first, second, and third normal form, to try to look at the content that you have in your spreadsheet or in your unnormalized data table, and start with like, all right, how can I create this environment, this object modeling that we were talking about earlier, to create this environment that allows us to have this data and implement that cleaner environment by using the third normal up to the third normal form. Referential integrity is what we use to get those tables to talk to each other. So now I've got 3 tables. Brian, it sounds like it was a lot easier to have one table because they were all in one spot. Granted, it may have been easier for that piece, but what we're going to be able to do with this content when we kind of slice and dice it, as we're going to see in a couple modules, is really blows away the idea of what we can do now with when we're in an Excel spreadsheet and we can go to the top and we can click the column header and sort of ascending versus descending. We're going to have a lot more we can do with that. So that's the good news. Referential integrity is getting those columns, those tables, to talk to each other. So this includes, or you'll see this referential integrity is RI. It's a concept to ensure that you have relationships between the tables that we just created. RI can ensure that the data is clean, and it makes sure that data that we're adding is valid data. So not only have we separated content out, we've now created an environment that's going to enforce that when I'm adding data, it's going to be valid data. And we're going to do that by introducing what are called primary keys and foreign keys. So if we go back to, I'm going to go back a couple slides here. If we go back to here, our student number is a primary key, we'll say. And what I can do is I can have it, or is a foreign key. And my bad again, my registration has a student number on it, and it also has a students over here in this table here. So we're both using 1022. So what we're going to do is we're going to reference one table to the other table. One table will have the primary key, and one table will have the foreign key. So the foreign key is used to validate the content or the value that I'm adding is a valid value. Kind of sounds a little bit redundant, but it's not. So if I'm using the students, my registration, when I go to register, it's going to look at 10022. When I enter in, if I typed in 1021, it's going to bebop over because that's a foreign key over to the students here. It's going to jump over there and say, there is no 1021. So not only does it enforce the referential integrity, it enforces that we're adding valid content by making sure a student 1022 exists or a student 1021 exists before it allows me to add content. So not are we gaining the normalization of having the ability to slice and dice, it's actually performing data integrity by ensuring that I'm adding content that's valuable. So if there was no student 1021, and I try to add content into registration, it's going to say, dude, I can't work with you because there's no student 1021. But being there is a student 1022, when they register for classes, it's going to check to see student 1022 exist in the students table. It's going to also check to see who the advisor is. And if there's information that we need about the advisor, we're going to be able to write query select statements to be able to retrieve that content. So that's the idea of primary keys and foreign keys and allowing us to be able to reference the content between tables. That's that referential integrity to get us the ability to kind of double check or cross check with the tables that are involved to make sure that the content that we're adding is valid and to make sure that we're able to retrieve this content as we move on down the road and we look at some of the select statements. Now, we'll talk more about this when we start looking at the keys, but with these keys involved, we can only have one primary key on a table. And there may be other cross checks that I want to perform to make sure they're valid. So we can also apply what's called a unique constraint or a unique key constraint. What this does for us is allows us to not only just do a cross check on an individual column with the associated or composite key, associated primary key, but also I can do cross checks on what are called unique. And what that does is enforce uniqueness for us. Triggers can be used to enforce referential integrity as well. They require some code. A trigger example would be every time I insert a column, it may be as simple as send an email to the advisor saying that there's a new student that's been assigned to you. So it could be that simple. When a certain action takes place, that trigger performs tasks or multiple tasks It could be as simple as sending an email to the advisor saying, student now 1057 has been assigned to you, so they receive an email saying that they have another student that may show up at their door looking for some assistance when it comes to the performing the advisor role. So that's referential integrity. Pete, anything you want to add to that?
You kind of just blew my mind again. I'm going to just back up.
I got to quit talking.
You went all the way to triggers and what happens with respect to referential integrity. When something is added to a table, you can invoke a trigger, which invokes functionality. And I'm still thinking about my CD library. I'm trying to imagine how that's going to come into play. So that's another super advanced topic. We're going to get a little bit in the next couple of modules. We're going to talk about some of the functionality you can do in a database management system where you can actually invoke some of the code, some programmatic code on an event or a trigger on a database. But I think we're going to get into a demo here in a minute where we'll be able to summarize some of this. But I think normalization, pretty complicated because I went from a whole bunch of columns in a single thing to a whole bunch of smaller pieces that have fewer columns.
Right.
So I kind of understand that, even though we're not going to talk about creating tables, like actually creating a table. We're going to talk about in the next module.
Right.
But now conceptually, I get the idea that I take this unnormalized collection of data, which is my CD library, or your original example of the inventory was a good one with a whole bunch of products and a whole bunch of metadata or columns about the product on a shelf at a grocery store, right? I can see how I might break that down by brand, or I might break that down by category. Category seems to be a common thread across all of these examples, which is pretty good, right?
Yeah, definitely.
But it gives us a logical way to put things together so that they're in discrete pieces where I'm going to be able to, I think, use them in a smart way to answer different questions about my data that I have a really hard time with in this sort of unnormalized spreadsheet-like view.
Exactly.
Right. Okay.
Yeah,
good.
definitely.
Yeah, I'm tracking you.
Good recap, definitely.
Yeah. But triggers, seriously, triggers is like 300 level.
Yeah.
So let's keep it on the level.
So we'll keep it. We'll keep it. I just want to introduce the fact there are ways, there are tasks, including triggers, that can be used to enforce referential integrity. We won't get that deep in this class, but they are out there for us. All right. So methods for enforcing referential integrity. We just introduced primary key, foreign key, unique constraint, indexes. We haven't talked about yet, and triggers. Here's the idea of a composite key. So I may have a column. I may have a table that, for instance, let's say we have a table that contains driver's license. And if I go in and my driver's license for Arizona is BR549, if anybody remembers that reference to something that's an old TV show. Anyways, if my driver's license is BR549 and I live in Arizona and Pete's driver's license is also BR549, how can we make that a unique key in a table? We can't by itself, but what we can do is include another column called issuing state. So now my composite key would be BR549AZ, his would be BR549WA. So now those two together makes that data unique. Okay, so that's what a composite key. The primary key has to be unique. It may not be possible by doing it with that one column. So we may have to use multiple columns. If we use more than two columns or more, it's considered a composite key. All right, so if you see that, because sometimes you might see where it says something about having a primary key is like, well, it's got 3 columns. Well, in order to enforce uniqueness, we need 3 columns. So that's what that's alluding to when you see that composite key option here. All right, so let's go. Still staying with referential integrity. We're talking about constraints now. Here's that primary key constraint, and I just mentioned this a little bit already, kind of jumping ahead. Primary key is on 1 or more columns. It's required to provide the uniqueness in a row, in a table. That helps enforce the referential integrity. Often it'll be referred to from another table using a foreign key. But a primary key is an attribute or a set of attributes that uniquely identifies that row. So if it's a set of attributes, it's that composite primary key that we talked about. A table can only have 1 primary key on it. Not 1 column, but 1 primary key that could be a single column or multiple column. And a column that participates in this composite primary key or individual primary key cannot allow null values, which means content has to be added there. So I can't just skip by when I'm adding content. So if you're going to make a column part of a primary key constraint, then it requires content being added to that. And you can enforce that when you're creating the columns, and we'll see that a little bit later on. So the primary key is used for that. The foreign key is used to reference that content. So the foreign key is a column or a combination of columns. If the primary key uses two columns like we did with the license number and the state code, well, the foreign key referencing that has to use that to mention to reference it as well. So it references it as a unique constraint that's created over there for that primary key. Unlike a primary key, a foreign key can have null values. So be careful on how those two are implemented because they're implemented slightly different. But you're going to see that a primary key is going to be accessed by the reference by a foreign key. So it's going to allow us to enforce that referential or data integrity by making sure that we have valid content when we're adding our content into our tables. So this is the diagram we saw earlier, and what I did, all we've done here is we introduced earlier on that we had the foreign key, which are the blue items, and we had the primary key, which are the red items. So now what happens is when I add a new product into the products table over here, when I type in a value for product subcategory ID, it's going to jump over to the products subcategory table and make sure that this foreign key references a primary key here. Now, inside of this table, it's like, oh, by the way, this is a subcategory. If I'm going to when I add an item to this product subcategory, it needs to make sure there's a major category, a top category. So it's going to check this table down here. So see how there's all sorts of cross-checking that's going on as I'm adding content. When I add an item here, it's going to double check to make sure that's a valid item here. When I add an item here, it's going to make sure it's a valid item here. This product category ID here is a foreign key that references the product category ID in the product category table. So all this cross-checking is making sure that when I'm adding this content, it's all valid content that I'm adding, and these tables are tied together. The relationship is built between these tables using these keys.
Can we talk through that one more time?
Sure.
Let's go look at that slide. So we have 3 tables. So I'm going to go back to your grocery store example here for a minute.
Sure.
We've got a spreadsheet full of all the products with categories and subcategories, and it's in one thing.
Right.
And I went through the exercise of denormalizing my data, which led me to creating these 3 tables. Yeah. And then with the referential integrity concepts, there are these specific relationships that include primary keys and foreign keys in these tables that kind of manage the relationships between these tables.
Correct.
Right? So
Perfect.
let's just go, I'm going to give you one example, and I'm going to try and talk through this. You can correct me if I'm wrong.
All right.
So in my grocery store, we sell strawberries.
Okay.
And so in this example, and you've got a whole bunch of columns, I'm not going to worry too much about them, but strawberry is the product. It's got some product ID, which is unique, and I can see there's a key next to it. So that's the primary key in the product table is a product ID. So we'll just say strawberry is number 1.
Okay.
Product ID 1, name is strawberry. It's got some product number that's involved in my inventory system. Its color is typically red. Those kinds of things exist about the product strawberry.
Right.
And then the product category, which is on the right side of the slide at the bottom, we're going to say that there's a product category called produce.
Nice.
Right? And the name is produce. And it will have a product category ID of, I don't know, maybe produce is 25.
Okay.
Right? So the subcategory of produce for my strawberry is going to be fruit.
Right.
Or berries or something like that, right?
Fruit sounds good, yeah.
Fruit, we'll call
I think
it fruit.
strawberry is fruit. I don't know.
Strawberry is a fruit and
It's
a
tomatoes.
berry.
Tomato's that weird one, isn't it?
I get confused
Tomato,
about that.
I think it's a fruit, and I think it's a vegetable.
We're going down a hole
we'll
I don't want to go into, yeah.
Okay, we'll stay
So subcategory of fruit has its own primary key for fruit, but then has a foreign key relationship to the category, which is produce.
Correct.
And then back on my product side, when I list the category, the subcategory specifically there of fruit, it's going to have a foreign key over to the primary key in the product subcategory table.
Exactly right.
So I've got this list of stuff that includes all of my products, and I started with a spreadsheet, but if I want to get it into a database, I have to denormalize it, which means I need to think about all the redundant data and how to simplify it down. And then I have to figure out how to have relationships between these tables that include primary keys and foreign keys so that I can keep my integrity of my data all together so that I
Exactly.
can uniquely reference things like the category and subcategory and the product name and those kinds of things.
Yeah.
Do I have it? Is that kind of what you're talking about?
Perfect explanation.
Okay.
Definitely, yeah. So those guys make sure the data is being added is valid data. That's good. That's what we want to make sure. Again, we've taken our denormalized table, our unnormalized table. We've normalized it. It requires some additional tables. We got to get those tables to talk to each other. They need relationships, and the primary key and foreign key.
And I can start to
create that.
see where we're going now, because in my spreadsheet, I have fruit listed in one column for everything that has a row that is a fruit.
Right.
So I've got strawberries and bananas and everything just says fruit.
Right.
But I don't have any idea how many categories I have, because fruit is listed 25 times
Exactly.
and crackers is listed 25 times and I don't know. But if I do it this way and I break my data up in these tables, then I can just look at how many categories I have, because it's only listed one time in the category table.
And that's back to normalization where we got rid of
I've
the
eliminated that
redundant
redundant data.
Absolutely.
Okay,
Perfect.
I can
Really
totally
good.
see how this is going to be a lot easier for me to use.
Yeah, and we start retrieving this content in another module too. The way we can slice and dice and generate information compared to our spreadsheets is going to be phenomenal.
Well, now I'm really curious how many genres of music I have in my collection, and I want to know how many records I have by a particular band.
Yeah.
And right now in my spreadsheet, it's really hard to get that kind of information out.
Yeah, you can filter, you can sort it and stuff. You can't,
yeah, but then I have
get a good
to
report.
count each row.
Exactly.
It's super complicated.
Definitely.
Yeah.
All right, so hopefully that helps clear up the idea of taking a table, normalizing it using a third normal form, taking the table, normalizing it, and now, okay, we've got all these tables. I got to get those tables to talk to each other. So we use primary keys and foreign keys to create relationships between those tables so they can talk to each other. And I'm able to validate content, and I'm able to see, you'll see shortly, to be able to retrieve content using table content that's stored or data that's stored in multiple tables. I'll be able to retrieve that content. So we're going to be able to go in and move that. All right. Do we want to try to do a little ad hoc
Let's do it.
library?
I think we should.
Want
Let's
to run
go.
with this?
I think we should work on my CD library right now.
Okay. Let's do this. So I need to come out of this screen so I can go into one of these deals here.
So in this case, you're going to be my database administrator. I'm going to tell you about my data, and I'm going to try and guess what sort of normalized form and things I need to do. But let's see if we can...
CDs, you said, right?
We're going to do the CD library, and let's see if we can create just the basic structures that we need for what I think the tables are going to become later on. And I'll talk you through, sort of like the grocery store example. But I have this huge spreadsheet, and it's got all of the CDs that I've got, all the albums. Right? So I need... and it's got a whole bunch of columns in it, like artist and genre and the date that I got it, and there's probably 25 because I keep track of a variety of different ways that I like to sort them.
Cool.
So, but let's just start with those three. It sounds like now we're talking about I need something to manage the CDs, but I don't want the artist listed redundantly, right? Because now that I know about normalization, I want to eliminate the redundancy.
Right.
So I probably need something to track artist.
Okay, so let's add a table here. So we're going to
start with the first one. Let's just start with the CD.
So we'll add a table. I'm just going to throw square. All I do is square boxes here. Let's get some fill factor on it for some reason. Let me get rid of no fill here. All right.
This is sort of the fundamentals of database design using PowerPoint.
Yeah, pretty much, exactly.
Right. Which we don't necessarily
recommend. There are
recommend.
better ways to do this. But.
Right. There are lots of tools actually that do this. In fact, Visio has some great designers for doing relationship modeling and things like that. But
so
we're going to stick simple here.
Yeah, we're going to just... What we're going to call this one? This first table is what?
I think we can call this CDs.
CDs, okay.
Although nobody buys CDs anymore, right? It's all digital, so maybe we should call it albums.
There you go. That's a
Should we call
universal
it albums?
name.
Let's call it albums.
Albums, okay, good.
That way we're modern and ready for
now it sounds
future
cooler,
media changes going forward.
Sounds better that way. So now we're going to go ahead and do this. We're going to have to add another table. Because you said you wanted to...
Yeah, I think the question that I want to answer about my data is how many categories or how many genres do I have? So I think I can kind of detect that since an album has a genre, and one of the things that I want to learn is how many genres I have. I think one of the possible things that we're going to need here is a genre table.
All right. Let's see here. I can't get this guy here.
Can you actually make that bigger? Do you want to just maximize your PowerPoint window for
sure.
me?
Well, let me do that.
That'll be
Yes,
great.
it will.
Maybe you can
Okay.
make that slide thing smaller too, and we get these boxes a little bigger.
Gotcha. Slide that. How about that?
Now I can see it. Good, thanks.
Nice.
Yep.
Good call. Look good
Yep.
to me. It's sitting right in front of me.
Right.
Get this centered.
So that's going to be albums, and then that one's probably going to be genres.
All right, I gotta figure out here. I get this fill out of this thing here. Fill.
This is really just a chance for you to demonstrate your PowerPoint
my
prowess
lack of skills in PowerPoint.
for all posterity.
All right, so and here we're gonna add. This is gonna be.
I think you just click and type.
All right.
Just click the box to select it,
There
and
it
just start
goes.
typing. That's going to be genre. Except now I think you've got white text on a white background.
Yeah. You can't see that? Really? I can see that perfectly clear. I don't know what the
Because
problem
it was originally blue and you made it white, and now. There you go. Okay, great. So that's genre. The other one is album, and then I want one more for artist.
Oh yeah.
Because I think it'd be really interesting to figure out how many albums I have from a particular artist.
Who's your favorite artist? Do you have a favorite? Really? So many nowadays.
You know what? I've been a drummer for as long as I can remember walking, so most of my favorite bands have really awesome drummers. The last band I saw live was the Dave Matthews Band. How's that? Is that a good
nice.
answer?
That's
and
good.
I have a whole bunch of his records in my collection, so
Okay.
that might be our example.
All right, and this is gonna be artist.
And that's going to be artist. So I've got this spreadsheet. It's got all my albums in it. I've got a whole bunch of metadata, including artist and genre and the date that I acquired it. But now with normalization, I can break those things down into these tables so that I can look things up like the list of artists, the list of genres. But now we have to do the relationship between them. So
right.
let's just type in these boxes then. I need primary key for everything,
Right.
right? So that I can give it a unique identity. So just click in the box, and what would we call the primary key for the album table? Probably like album ID.
I would say
right?
album
Does
ID
that
would
work?
be the easiest one. I don't know why it keeps defaulting to white text.
It's because we tricked you and you changed the color of the box the first time, but that's fine. Good. So that's going to be album ID. And that's my primary key for that table. Can you just maybe put in parentheses, that's primary? Yeah, that's great. So album ID is over there, and then we probably need primary keys for the other ones also, right?
Yeah.
Just
So-
put it after artist. Just hit return there.
It's let me jump back in here.
There you go.
Then hit there. Oh. Yeah. See, this guy here doesn't like.
You need to get your insertion point on it.
There it goes.
There you go.
Artist. Okay. This PK is going to be.
Artist ID probably, right?
Sounds good.
I'm sensing a theme here. I think we're going to probably talk about some naming conventions and stuff like that in the
Yeah.
next module.
Yeah,
but
absolutely.
just conceptually here, I have a primary key there, and then I've got another one there for genre. I'm going to guess this is going to be genre ID.
That looks consistent to me. Did I spell that correctly? I don't know.
Yeah, that's right.
Okay, good.
It's good enough for the example anyway.
Yeah.
So primary keys gives us unique identity for all these things, but now I need to have a relationship between them so that I actually can do the lookup things that I want, like how many albums do I have that are in the jazz genre,
Right.
right? So how would I make a relationship between genre and album?
So we need album ID to be able to access genre to check for that.
Album ID so I can check for genre, and conversely, I probably want a genre ID in my album table,
Correct.
right?
So I can get typed into here.
So which one do I want? That's actually a really good question. Do I want an album ID in my genre, or do I want a genre ID in my album?
You want genre ID and as a foreign key in albums. That's
Okay.
going to reference the primary key in the genre table.
Got it.
Okay.
So that becomes a foreign key in the album table.
Right.
And then we don't have to draw the lines between them like
Yep,
you
but
showed
these
us
would
on the
talk
other
to each other,
slide.
yeah.
But the genre ID in the album table is the same genre ID. So if I have Dave Matthews Band live at the Gorge, which is complicated because it's a 3 CD album. We'll call it one album. We're not going to go there right
Yeah.
now. How many CDs are in that thing? But if I go to the Dave Matthews Band album, then it'll have a genre of rock, but it'll have a genre ID in the album table, and the genre ID will map to the genre name in the genre table.
Correct.
So that I can say, how many albums do I have that are rock? I can look up by rock, and I can find Dave Matthews. Is that roughly what's going on here?
Yeah, somebody actually add a name here. So
Oh yeah, genre name is probably a good idea.
yeah.
So we don't have to do the whole data model,
Yeah,
and I think we've got a couple of examples now.
Yeah.
But tie in that first example of that giant spreadsheet. We've got products, we've got categories, now we've got our CD library, we've got albums and genres and artists. And I imagine just to complete this thought, we'd have a foreign key in the album table that is the artist, so that not only can I look up my albums by genre, but I could look them up by artist.
Exactly. We'll
So
add that
suddenly
right
my
there.
complicated spreadsheet that has, however many hundred rows in it becomes broken down in a normalized relational model with the referential integrity so that I can look things up between them in a really simple way. And we're just totally foreshadowing where we're headed in modules 3 and 4, where we're going to talk about how you actually create this in a database. Look at you trying to draw the lines in PowerPoint. That's very adventurous of you.
Yeah, I know.
I
Especially
think
because
that's
I
a
can't get the
slippery
typing
slope,
to work.
right? So we're in module 3, we're going to talk about how you actually create these in a database. We're going to use SQL Server as our example.
Correct.
And then in module 4, we're finally going to get to the query fundamentals about how I can do the lookups and do really cool stuff using the T-SQL language.
Yeah, and that's cool. I think that's would be the
use
cool
the
part
data.
where this is where it really comes together. Like you're used to being in your Excel spreadsheet. It's like I've got limited functionality. By creating this and doing this, performing this data modeling, the normalization process, creating these tables, creating the relationships between these tables. When you start looking at some of the complex select statements, not real complex, but some of the slightly advanced select statements, you're going to see the power of why you would want to do this, especially if you have lots of rows of content.
Let's go on to the summary slide, and then I think we'll wrap up and we'll get on to module 3.
So we talked about normalization. We talked about, remember, there's 5 forms. And we talked about 5 normal forms for that. Let me go big screen here. There we go. And first one, second one, and third one. We're worried about those the most. That's going to give you, you're going to eliminate repeating groups, eliminate redundant data, and it's going to eliminate any content that's in a table that's not relevant, has to be directly associated with that key. So we're going to do that first. We're not going to worry about the 4th and 5th normal form. Referential integrity, we talked about that. That's what ensures the data that we're adding is valid. We saw that with the cross-checking. When I add content, when I add an album ID, for instance, it goes out to make sure it's a valid album ID. Or if we go back to the student, it goes out to make sure we have a valid student or we have a valid advisor. Tools we can use for referential integrity. We showed you a quick demonstration. Ad hoc kind of worked okay. Primary key and foreign key constraints. Again, if you want uniqueness in other columns besides the primary key, you can use a unique constraint. And we'll look at indexes a little bit more down the road. And we just did a brief explanation of triggers, just so you know you have that option that's out there. This is a brief explanation of those different types of constraints that we have available or ways for us to enforce referential integrity. And we demoed primary key, foreign key. Unique constraints will probably be very popular when you're trying to enforce uniqueness and you've already used your primary key for a table. And a unique index is going to be created for you when you create a unique constraint. In fact, we'll talk a little bit about indexes, not a whole lot about that. And then we introduce the idea of triggers can be actually used for kind of introducing some code that might help with enforcing referential integrity by ensuring that someone, did you really mean to delete this particular item? So you can actually use a trigger for that as well. So what we looked at here was more conceptual. We looked at the idea of normalization. We talked about that. We looked at introducing constraints. And we attempted to draw out a diagram on how you might take your album collection, I like that better than just CD or DVDs, and use something like a database product like SQL Server or even Access to take it out of the spreadsheet and give you that extra flexibility and start introducing the idea of relational databases and tables within those databases. So we'll be back and we're going to continue on with our conversation in just a little bit, and we'll continue on and continue discussing what we're going to do and how we're going to really utilize the options of the referential integrity that we've just introduced. And we're going to get more hands-on with what we can do in the upcoming
Going to finally create
courses.
a database?
Yeah, we're going to start creating some stuff.
Fantastic.
Now that we've been kind of setting up and how we want to do it, we're going to dig in and kind of roll up our sleeves and start doing it.
Welcome back to Database Fundamentals. This is the beginning of Module 3 of the Database Fundamentals course. Module 3 is going to be a fun one. We're actually going to talk here in this module about creating databases and database objects. So
we get to create something finally.
We finally actually get to do something real instead of all this theoretical stuff that we've been doing. But let's just review. In Module 1, we talked about sort of core concepts of databases, some terminology, things that we've covered. Then in Module 2, we talked about, what did we talk about? We talked about referential integrity and normalization and sort of a little bit of modeling, but not quite modeling. We didn't get into some of the details of modeling, but we talked about referential integrity, normalization, a little bit about constraints. And now here, finally in Module 3, we're actually going to create our first database.
Yeah.
We've only looked at diagrams so far, except for your quick demo of SQL Server Management Studio. We're going to create databases. We're going to create database objects. You're going to tell us what kind of objects we're going to create, things like that. And then in 4 and 5, we're going to head on, coming up, we're going to talk about how we actually use those objects with the T-SQL language in Module 4 and then administration in Module 5. So
some real work. Some real stuff now.
Let's create. I can't wait to see how this is going to go.
So yeah, creating databases and database objects. First thing is we're going to talk about data types, because before we can create objects, specifically a table, we need to understand what types of data we're going to store in there. And that's really huge about, it's huge to understand. So we've kind of talked about creating different columns. We've talked about creating the artist ID and the album ID. Well, we need to identify what type of data is going to be stored in each of these columns. So it's not as easy as it is in Excel where you just throw a column out there and just say, yep, just throw whatever you want in that data in that column. We actually have to think about, this helps with the data integrity, we have to think about the type of data we're going to store there. We're going to store numbers in there. We're going to store money. Is it going to be a date field? Is it going to be a character field? And we have all sorts of options. So we're going to introduce data types first. You have to have an idea as to the type of data that you're going to store. That's something you need to do and think about in that data modeling phase that Pete had brought up earlier. So we'll look at data types. So we'll look at database objects. We're just going to mention just a few of them, the most commonly used objects. And then we'll look at DDL, data definition statements. So statements are used for defining new objects. So we'll introduce those statements that are available associated with DDL statements, and then we'll use a couple of those statements just to show you how they all work together with us. So data types is going to be our first category that we're going to talk about. And in here we're going to begin with an understanding what that is. So we've talked about rows and we've talked about columns. Well, the columns are what we use to identify that we assign a data type to, which identifies the type of data that's going to be allowed or stored in that particular column. You have similar data types. There might be a couple different data types that are similar. The idea is use the data type that has a larger range of values just to make sure that you have a better chance of increased precision, and you make sure that you don't have an overflow error by not having a data type large enough to be able to store the content. Some exact numeric data types are int and tiny int, and these are probably the most commonly used data types because they're storing numeric information. And then we have approximate numeric types. These include precision, so it's indicated by a letter P, and that gives us the total number of digits, decimal digits, that can be stored both to the left and to the right of the decimal point. So all of this has to be considered when you're trying to decide what columns am I going to create for my new table, for instance, and what type of data am I storing in there. When we talked about the album ID, is normally going to be, most likely going to be a numeric type value. Description or title or artist, that might be more of a character field. So these are things that we need to think about. The other thing we need to think about is how are we going to use these forms, these columns or data types. For instance, if I go out and I create a data type of a character field and I put a number in there, I'm not going to be able to use that in a calculation. I can't multiply in a character field. It has to be a numeric field for that operation to take place. So there's some things that we need to be aware of when we're working with our data types. We have what are called Unicode data types. You'll see that often. These provide storage for international characters. So non-Unicode data types are pretty much specific to the USA and the New England, or not New England, English data types or characters. But if you want to bring in other languages, native languages, we have to use the Unicode data types. Unicode data types take more storage in the database itself, but so you have to be careful about that. But those two things are a couple concerns that we have to think about when we're looking at data types. Now, there are several categories that are provided with us with SQL Server 2012. And I mentioned already we have exact numerics. We have big int, and we have bit, we have decimal, int, money, approximate, float and reals, date and time, I mentioned that one, character fields, Unicode character strings. Then you get the letter N before, that means it's Unicode. That provides support for the international languages. Binary strings, and we have some unique data types, other data types like a timestamp or a unique identifier. Some of these are actually taken care of or managed by SQL Server. So it actually, timestamp, for instance, it stamps, takes a system time, it stamps that or applies that to the record as you're applying that. And we have a couple other ones, large value data types and large object data types, which we will see for storing images or specifying the maximum amount that we want to allow in a particular field. So data types we have to understand how we're going to use them, and understand they're going to enforce data integrity for us by, for instance, if I have an int or a tiny int, I'm not going to be able to put the letter A in there because that's a character field. So it enforces data integrity with the use of, by enforcing the information that's being supplied. It also controls what we can do with that content or those values once they've been added. So we have to make sure when we're going through this that we think through that as we're creating our data types here. So here's a couple common ones. We've got money. So if you're going to store currency, you can control these. Most of these have options where you can decide how many decimal points that you want to the right or the left of them. We have int, used to store whole numbers. We have a float, sorry.
Is int short for something?
Short int, yes. Int is short for integer. Thank you very, very kindly. Yes. I see, I just assumed.
You blew right past that one.
I blew right by that. I did
right.
a couple times. So the tiny int is tiny integer. Or the int here that we see here is integer. Big int is big integer. So some of those short names, I'll try to be more aware of that. Thank you for catching me on that.
But I also want to back up before you finish this slide. You've gone to a list of the sort of kinds of data types, numeric and non-numeric, and then you've gone into some specific data types that are actual keywords in SQL Server. So two things I wanted to say. Number one, it's specific to the database system that you're using. So right, you're talking about SQL Server, which is important because that's what our demo is going to be. But there's a different, shorter list of data type choices in Access and in other database systems,
that's
right?
Correct. Exactly.
And they're very similar, but that's one of the ways that the choice of what database you use, what database engine you're going to use,
right.
That's one of the deciding factors. Is if you need unique identifier or some of the really advanced data types, you might need to use SQL Server because it may not be available in Access or a smaller database engine.
Yeah, both, like you said, most of the relational database products associate with the ISO, the standard for databases. So if you learn one database, you don't have to jump over and learn a brand new data types. But Microsoft SQL Server, as other products, have some unique variations of what is available or supported, we'll say, via ISO. So,
great.
ISO, what does that stand for again? International Standards of Organization.
International Standards.
Yeah, one of those
trivia
things.
question.
Yeah,
that's right.
It's a trivia question. There we go. So that's all right. So we have int, short for integer. We have float. That's often used if you need a more precision. We've got more in the scientific community, and then often we're looking for dates or times and stamps. So we have a date time field as well. So those are a few of the variation of those types of data. Getting the more of a couple other ones are char, short for character. And anything can go in a character field, so we can put numbers and alphabet in there. So it's a alphanumeric characters can be stored in there. Variable character, so a char, which is short for character, has a fixed length. So if I do a char 20, it's going to allocate 20 spots for 20 bytes, I believe. Bytes or bits? I can't remember that.
I don't remember.
20 somethings. Jars. So it's going to allocate that number. Now, if I only use 4, there's going to be 16 unused. So it's a fixed length. A varchar, variable character length, if I put 20 in there and I store 4 bits of information, then the other 16 bits, it's only going to allocate what is needed to store the content that's in that type of field. So that's the difference between those two. Another data type is a bit. Sometimes you'll see it as a Boolean. This is often just going to return a 0, which is false, or a 1, which is true. So it may be as simple as, you know, if I want to go out and check, does the date field equal today's date? And it returns yes, or a 1. If it does, then, you know, we can have some programmable code or programmatic code that allows us to go out and perform some other task. We can do some calculations. We can do calculations within the fields themselves, just using the data types that we're creating. We can also use something like the date time offset, where we can actually determine the difference between a couple dates or the offset of those dates. So some of that functions available to us. Here's an example of some of the different data types in the storage. For instance, as you can see, the int, short for integer, can store a number from minus 2,147,483,648 to plus, it should be plus 2,147,483,647. So it's 2 to the 31st if you look at it that way. You know, char, for instance, fixed length, non-Unicode data, any value from 1 to 8,000 characters. The bit we talked about already, and the date time offset we talked about already. So these are, again, things that we have to consider when we're creating our new tables, when we're trying to create our relationships between those tables. What are we going to use the data for? We could just easily create everything in char or varchar to save space, but when we do that, now we have issues if we need a date, a timestamp, or if we want to try to perform a calculation. We'll have some restrictions with that. So we have to think through this when we're going through the data modeling and designing our tables for our database. So these are some examples of the size of the information and what's stored here. Now, we may have a situation where we created a data type on a field and we want to perform a calculation on it. Well, we can do what a SQL Server will do is what's called an implicit conversion. So there's implicit conversions and there's explicit conversions where I need to do the conversion myself. I need to use either cast or convert. Either of those commands allows me to take any of these data types and convert it, I won't say any, most data types, and convert it to a different data type. So if I want to be able to perform a calculation, as long as the number was in a character field and I want to convert it to, you know, an int so I can perform a calculation, we can do some data type conversions as part of our program, and we're doing some programs and using some of the different objects inside a SQL Server. But the best thing to do, if you can, is to create the data types with the create the columns with the appropriate data types, taking into consideration the type of content or data that's going to be stored in there and any type of calculations you may be performing with that data once it's actually stored in there. And there's an example here in the slide of casting, you know, $157.27 as a varchar. So it's going to convert that and now store that as a varchar and be able to work with that using that new data type here. But again, not everything's supported. For instance, an nchar cannot be converted to an image data type. Most everything, as you stay within the common data types, you're pretty safe. But if you're going to get into some more unique ones, like image, those you have to be a little more cautious about. So we talked about we introduced the ISO. The cast and the convert can both be used for doing explicit conversion. The cast, as you can see, it's recommended you use that because it does adhere to ISO. Now, Microsoft or other products have decided to create another flavor of that called convert, and they can do so and still take advantage of that and still use it. Just gives it a little bit of a different variation. So data types, you have to understand those before you create your objects. We're now ready to create our objects. Here's our table we looked at earlier already, collection of rows and columns. We have our employee ID. Maybe that ID has a tiny int or an int data type. Last name is a varchar. First name is a varchar. Department might be a varchar with different lengths. Maybe we have a varchar 30 for last name, varchar 20 for the first name, department of varchar 25. We define that when we create these. And the employee ID, we decide, hey, are we going to go above a certain number? If we are, we need to decide if it's a tiny int or an int. or any of the other types that will hold a numeric value for us. Now, in addition to tables, which we're going to use the most often, we have what's called a view. A view is a virtual table, and it consists of columns from either one table or multiple tables that we've pulled in, and we're going to see how one of these are created. A view is not really an object that's stored inside of the database. It's more of a query. So when I go out to use a view, it's actually going to go out and generate that information on demand. So it's not going to populate the content in the view when I create it. It's going to take the select statement, we'll say, and it's going to use that to populate and display the information that I'm looking for when I'm trying to create a view here. And here's some examples of some system views that are provided by Microsoft that are part of the SQL Server world. Stored procedures. These are just a group of transact SQL statements that have been compiled and saved so they can be used multiple times. So I may go in and run the same command multiple times. If I'm doing so, what may be easier is to create a stored procedure that I can reuse. And every time I want to perform a certain task, and in this case here, we're looking at the number of items in inventory, going back to talking about what we talked about earlier in a grocery store, for instance. I want to find out how many items are on hand. Well, I can write a stored procedure, and instead of having the stored procedure hold not being flexible enough to be able to be run against multiple products, I can actually have parameters passed in. So I can supply a parameter to go look for, strawberries in the produce department by supplying parameters. The next time I can run it and have it to go look for, steaks in the meat department. So I can create a stored procedure that can be run multiple times over and over again. It actually gets compiled, which means it's going to run a little bit faster, be a little bit more efficient. And we can pass parameters to it so I can run it and reuse it multiple times and be able to get results back based on the parameters that I passed into it. So this is just a brief little example of how we use that and to pass parameters into a stored procedure. We can create UDFs or user-defined functions. These are routines that also can take parameters. It completes a specific operation and returns the result of that operation. And there's a few different types, and we'll see these as a couple of these at least we'll see as we're going through some of our demonstration between this module and the next module. But we have a scalar function, which is going to return a single value. So we're going to see, for instance, I want to know the average cost of something. So it can return that information to me. We have a table value. It returns a table data type. We're not going to see that one. I'm just listing a few things out here. And we have system functions, which are functions that are provided by SQL Server in this case here. And we can use those in any of our statements that we're writing, for instance. So we can use that pretty much anywhere we want to return any system type information. So a few different types of functions that we have available to us. And pretty much for this class, we're going to just focus on the scalar function and what kind of information can be returned with that here. As I introduced the stored procedures and the functions, they sounded similar, but here's an example of the differences. In order for me to execute a stored procedure, I use the execute or exec statement. I can't use join stored procedures. I can't join multiple procedures together. I can't use a stored procedure for modifying SQL Server, a configuration of it. And I can't use statements such as a get date in a stored procedure. Now, user-defined functions allows me to perform some of these tasks. I can call from within another SQL statement. So I can call a function from within another SQL statement. I can have multiple UDFs working with each other. It cannot be used for SQL Server configuration. Stored procedures can. The user-defined functions cannot. And if there's a problem with the user-defined function, it's going to stop the function and it's going to no longer continue on. Where a stored procedure, depending on what kind of error checking you've done, will continue to perform. So just a few high-level differences between stored procedures and user-defined functions as you're creating these different objects. Now, one of the things that we often do as we create objects is we have to have a naming convention. Now, a couple of the common ones are listed here. The Pascal case is where we use the first letter of the identifier and the first letter of every subsequent concatenated word is capitalized. So, for instance, you see employee table. The E in employee and the T in the table is capitalized. Personally, this is my preference, and I use Pascal case, and you're going to see with the scripts and some of the content that I'm going to be showing you in this module, the next module, I'm totally about Pascal case. Camel case, as you can see, the difference is, with the exception of the first word in the descriptor, the identifier, the first word is lowercase, and then every other word, every concatenated word is now is capitalized. So the first letter is capitalized. So whatever your choice is, whatever your preference is, mine, as I've shared a couple times already, is Pascal case. But whatever you're going to use, be consistent. So when you're starting to rename your objects, if you decide to use Pascal case or camel case, use the same naming convention for everything that you're doing, so you don't get confused as to why you used it one place and something different in another place. And try to keep that as a standard within your organization, so you know you've got that consistency when you're creating these objects that we're going to be creating here. Okay. We're going to go in and create a database. There's a couple ways we can do this. We're going to show you both ways. We can do it inside of SQL Server Management Studio. We're going to jump over there. And we can also do this inside using a transact SQL statement. We'll show you how both of these work for us here. So let me jump out and go into my...
This is pretty exciting. This is our first actual database.
Yeah,
We've only seen pictures of databases so far.
Yeah, and the pictures weren't that...
Well, the quick one you showed us, but we didn't actually...
It wasn't that cool. Yeah. Well, a database can be created very easily. I mean, it's kind of like I showed you. This statement here is probably being the easiest statement you can write. Select asterisk from production.product. That's a pretty straightforward statement.
But somebody had to do the creation of the database, and then they had to create production.product.
Yeah, that's that whole schema with all the...
That's the table. So they went through their spreadsheet and figured out what tables they needed. Yeah. And once we create our database, we're going to go and we're going to talk about creating a table where we're going to use all that stuff you just taught us about the data types.
Perfect.
And then this is actually the foreshadow to the next module, where we'll learn all sorts of different ways to write queries that get the data out of the database.
Yeah, exactly right. Yeah, and that's the big thing. I mean, all the upfront work that we're spending time on, that you talk about, Pete, is really, it's not. It's kind of, it seems like there's a lot of upfront work in getting the tables and getting the foreign keys and the primary key constraints. But once that's all done, the big bang for the buck we're going to see in the next module, you're going to see how much easier it is and more efficient it is for us to be able to retrieve that content and slice and dice it in several different ways. So let's create the easiest way to create a database is go in here to the SQL Server Management Studio, and over here where it says databases, I'm going to right click and do new database. And here's a name right here. So I'm going to call this class demo DB. Now, quite honestly, I can right here, find my mouse, come back mouse. There it is. Must have been off in the real. I think, was it over on your screen? I don't know. Lost it on my screen. So I'm going to go ahead, and this is how simple it is from inside of here. Now, there's options that we can change here, but I want to show you how easy it is to create a database. All I did is give it a name. All right. I'm going to click OK. And if you look over on the left-hand side here, we've got a new item here called Class Demo Database. That's how easy it is to create a database in here.
Woohoo!
Now, was it efficient? Did I do everything I could have, should have done to make it as optimal as possible? Absolutely not. But I wanted to show you, if you want to do something today, say, hey, create my first database, open up SQL Server Management Studio if you have access to it. Remember, SQL Server Express is out there if you want to dabble with this. And then go in, right-click database, give it a name, click OK, and go out and have a baby, because you just created your first database and you're into the SQL Server world at that point. Again, a lot more we can do. To make it a little bit more complex, let's say we like to type. We want to practice our typing skills. I'm going to actually go out. I created a script file the other day, and I'm going to open up a script file. I'm going to talk a little bit more about scripts. I'm going to open this up here.
We should talk, while you're doing that, we should probably, you've referenced this thing called T-SQL. Can you just explain what you mean by T-SQL?
T-SQL is like in golf when you tee up. It's not like that at all. Okay, so I do know that much. But T-SQL is Transact SQL. It's Microsoft's flavor. We talked a little bit about ISO standards just a couple of minutes ago. So whether you're using SQL Server or using your MySQL, or if you're using Access, they all have a different flavor of statements that you're going to use. They're all very similar. We talked about that. Most all of them will adhere to the ISO standard. I know it sounds redundant, but saying ISO sounds weird by itself. So most will all adhere to that, and then most of them will have variations. They might, like, for instance, we had the cast, but we have a variation of it, which was convert. or so we can have variations of the different commands. But T-SQL is Transact SQL, and that's Microsoft SQL Server's flavor of issuing or writing commands, as we're going to do. So when even doing that select statement, that was a T-SQL statement. Creating a database, as we're about to do, is a T-SQL. So anything that we do, pretty much anything that we do, even inside of a stored procedure or inside of a function, it's ways for us to query or manage or manipulate data inside of SQL Server. Is that clear? Does that make sense?
Yeah, that's better. Because you're about to go ahead and open that file,
Yeah.
which we're going to use for the demo, which is full of these T-SQL commands.
So the cool thing is what I've done to so you guys can see, if you trust me, Pete was watching me type yesterday, he fell asleep. Because I'm fat fingering stuff, I don't have the proper quotes, or I forget a quote, or I got too many quotes, or it was just always making mistakes. So what I've done to avoid the pain for you folks is I set up these queries, and I'll show you how to execute them, and I'll explain what every one of them means as we're going through them. So I just showed you an easy way, as easy as it gets, to create a database. I go into SQL Server Management Studio, I right-click on Databases, I do New, I add a name, I click OK, done. I create a new database. Now, if you like to practice your typing skills, here's another way we could have done that. All right, a little bit more complex, but let's walk through this. This is a Transact SQL statement. This is going to create a database called sales, and then and we're going to give it a logical name called sales underscore dot. And whenever you create a database, it gets two files that are created on the drive, and I'm happy to store these on the on the C drive. And my sales.mdf file is created, and that's going to store my content. And the size of that's going to be 10. The max I'll let that size of that file go is 50. And if it needs to stop and grow, it's going to grow in I call baby increments, 5 megabytes at a time. So what this does for me, when I create this file that's going to store my content, the size is going to be 10. If I'm at 9 and I try to add a 4 megabyte file, I'm short 9 and 4, 30, I'm short 3 megabytes. So what this does, like, well, I've got auto growth on, so it's going to grow, it's going to stop, it's going to grow by 5 megabytes. Now it'll let me to continue to add that content. The bad thing is it's going to keep doing that every time I need to add content. So different story, but we can actually change these and set these to be a little bit more appropriate values.
But I think specifically, you showed us you could right-click and do Create Database, and you alluded to a whole page full of options that I could have set.
Yeah.
In your script is using the Create T-SQL statement to create a database.
That's exactly
right. And
right.
it's specifying a variety of those options in code. So you can do it with the graphical user interface.
Perfect.
Or you can do it with code. It's just a different way to create the database.
Yeah, I just showed you the easiest way to create the database was right-click, bam, you create the database. You're exactly right. If I went in there and looked at options and I looked at files, I could change that so the size equal 10, the max size equal 50. I could specify the file name, the file location. I just wanted to show you just to give you the opportunity to create a database. That was the quickest, easiest way to do that.
And I think this is an opportunity to call out. We've got a bunch of training about SQL Server specifically, and in the database administration course that we have, you can actually learn all about the different ways to create a database for optimal growth and minimal size and those sorts of things that you're calling out in your script here.
Yeah, optimizing databases. Again, this is the DB fundamentals, so trying not to go too deep. Hope Pete's keeping me on track with that because I start digging deep, and next thing I know, I'm like.
Well, the concept is sound, right? In Access, we can create a database by doing file new because it's more of it's a desktop. It's not a database server product like SQL Server. And in MySQL, there's a way to create a new database, and they all have these kinds of parameters about how big should it be and what's the file going to be on disk and those sorts of things. But the concept is it's a simple create statement. SQL Server uses this query language called T-SQL that you can use create, or you can just right-click in SQL Server Management Studio to create the database.
Yeah, so it depends. If you get paid by the hour, you'll want to learn how to type these in. If you get paid, if it's just getting the work done.
But show us that it runs now. I don't.
You don't believe me?
I want to see it happen because you did one with the graphical user face.
Right. So this is.
I also want to see. You've got a whole long page of scripts there. I can't wait to see what we're actually going to do.
I got some other cool stuff in here. This one's a small one compared to the next module. So this is the MDF, the data file. It also uses something called an LDF file, which is a transaction log. Again, all of the most relational databases uses what's called a transaction log style. So every data modification, not retrieval, but modification, is stored in a transaction log file, in this case here in SQL Server, stored in a transaction log file, and then it's written, eventually it's written into the MDF file. So it's just a temporary location. It's strictly there, it's primarily there, I'll say, for data disaster recovery or data recovery. So we need to supply that. It built that for me when I used the right-click new database. It promise you if I go out there that content is stored there. I didn't get to specify where it went like I can here though. That was stuck in this the default location, which is way deep in the C drive somewhere. I've created this to show you that you can specify where you want these files and what the name of these files when you're using this command. All right, let's see if this thing works. Now the cool thing is it's back in the query analyzer or query window here. It will only execute content that you highlighted. So you notice I've got some commands. I don't want these to run down here yet. So I'm going to highlight this content up here. And I'm going to go ahead now and I'm going to choose the execute up here. Or I can press F5. So either way will work. And it's going to go out, it's going to execute this command. Hopefully it will execute this command and create a new database called sales. All right. I'm going to head, I've got it highlighted. I'm going to press F5 on my keyboard. It comes back and tells me command completed successfully. Well, if I go over to databases, what's it called? Sales. I don't see it here. So let me right click and do a refresh. And here's my new database called sales. And if I want to look at the properties of this real quick, and it'll just be real quick, you'll see, just go with files for instance. Here's my 10 and my 5, and here's my auto growth. And again, as Pete pointed out, I could have done all this when I was doing the window, when I was going through the graphical user interface. I chose to show you just the quickest way for you to create a database, and that was the quickest way. And this is another way, if you get paid by the hour, to create a database is to write scripts. The cool thing about scripts too, I'm making fun about getting paid for it, but scripts are beautiful in the sense they're reusable. So this is another reason you may want to script some of this content here. All right, let's see if I can get this window back. I don't want this window so big here. Let's get this back down a little bit. Okay, so we have a database out there. Now, remember I talked about the use option. I need to add a table to that. So the idea that we talked about just previously was, hey, when you create a new table, you need to understand the type of content you're going to store in there. So this table I'm going to create is called products1. We're going to have a field in there called product ID. We're using an integer value. All right, so I can store whole numbers in there. We're going to have product name varchar20. We're going to have unit price using the money data type, and we're going to have product description using varchar50. Remember, if it's char, if that was a char 50 versus a varchar, even if it uses 10 characters, it's going to allocate space for 50. So it's a fixed length, where a varchar says only allocate whatever you need to store the content. So if this product description is only 10 characters, it's going to have storage for 10, not 50. So there's not a lot, so it won't be as much unused space. So what we're going to tell it to do is use the database we just created called sales and create this new table in there. So if I go over under tables over to the left right now, you're going to see system tables, file tables. Those were just tables loaded by default. Let's create our new table here. So I'm going to go in now. I'm going to highlight this because I can just highlight what I want. And I'm going to execute this. And command completed successfully. Let's do a double check over here. Let's go back to sales and do a refresh. And go back to our tables. And you'll see we have our new table here called dbo.products1. And if I expand on that, you'll see our columns. And you'll see the 4 columns that we specified here were also created there. So easy enough now. We've created a database. We've talked about what data types are. We've decided the type of content that we're going to store in that database. We're going to store in this products1 table. And we've created a table now that will allow us to be able to enter content in there. We're going to talk about doing that a little bit later on though. Remember, right now we're talking about a data definition or DDL statements. We're talking about creating objects and modifying objects. So we created a database, we added a table to that database. Something else we can do, and so notice when I created a database, I used the create statement. If I created a table, I used the create statement. I create a view, I create a store procedure. Whatever I create, if it's an object inside a SQL Server, I use the create statement. So it makes it simple for me. If I want to change the database, or I want to change a table, or a procedure, or a view, I use the alter statement. So I create a database called sales. I want to change that database name to sales forecast. By the way, that little green line that says right there what I'm doing, that's a comment. So anything that's got dash dash and it highlights it. Notice the color coding, by the way. The blue is saying these are actual statements. These are the fields. These are values that are supplied by Microsoft SQL Server. The dash says this, ignore everything to the right of that. It's just a comment. So you can document. People always document late, but they always document what's going on here. So this is a reminder to me, oh, I want to change the database. I can highlight it and try to execute it. Nothing's going to execute because it's a comment. But we're going to alter the database called sales. We're going to call it sales forecast. We'll hit execute up here. All right, the database name sales forecast has been set. Let's refresh. And we'll go over here. We'll see now our database now is sales forecast. So now we've changed the name of our database. Now if I want to delete the database, I've been asking Microsoft for years to change this from drop to toast. I like the command toast. I want to toast a database. I want to toast a table. It's still not toast. You can write a stored procedure to do that, though. You can write a stored procedure to do the same thing as drop, and I've done that before. But we won't go there. It's bad. It's just going to stay with standard stuff here. So I want to drop the database, or I want to drop a table, or I want to drop a view. I use this statement right here. Toast the database. We're going to highlight this. So remember over here we got sales forecast. We're going to execute. Ooh, cannot drop because it's currently in use. I must be connected to it somewhere. Modify name, toast the database. Let's see here. I know another way we can do this. Go over to the right, and I can do a delete here. Now what's happened is I have a connection to it. So because that failed, I'm going to come over here. There's a connection to it. So my guess is if I do OK here, it's in progress. It's already taken too long. It's going to come back. It should give me pretty much the same type of deal. It can't do it. And they're going to take this long, or else I wouldn't have done this piece. But it's going to come back, but I'm almost positive it's because there's a connection established to it. And so what I'm going to do, okay, now it fails. Drop failed for database. Let me do this. Let me click this guy right here. Close connection. And do an OK. Hopefully that will do it.
You know why they don't call it toast, by the way?
Why?
It's because toasting the database would make it more delicious.
Oh, that's true. Usually it's
Right.
fatness. That's true.
Yeah.
That is true. All right, we got rid of our database. If you look over here, we got rid of it here. I couldn't do the drop database. There are parameters you can supply with that to drop existing connections, so we could have done it that way. But because I had established a connection to it, it wouldn't let me drop that database.
So it looks like a lot of the things that you can do with the user interface in SQL Server, you can also just write script to do.
And scripts, we're going to talk a little bit more about scripts. This is kind of an introduction to them because I want to bring these in so you didn't have to watch me fat finger everything. But scripts are really powerful, especially if there's redundant tasks that you're performing. And let's say I wanted to hand this off to Pete so he can go out and create the same database. I just send him this script. He can pop it into his SQL Server Management Studio. He runs it. He's got the same database with the tables and the alteration of it if he wants to. So it's easy enough to redo information or tasks that we're performing here. All right, let's jump back out into our slide deck. That's not where I wanted to be here. I need to drop this guy this way. No? Yes? Or am I going too far here? Oh, I'm coming way out. I know what I need to do. I'm coming out of my connection. I need to minimize that. Here we go. And let's go back into our PowerPoints, which somehow got closed. We're in what, Module 3?
Yep.
Yeah. All right, come on now, work with me. There we are. All right, so that's creating a database class demo DB. That's the one we created using the interface. And the one that we created, that we're going to create, we also created one using a script. And we deleted that one after we had added a table to it. DDL statements, that's kind of what we just did. So we actually did the create of the database. All right, and we did the create of the table.
Remind me what DDL stands for again.
Data definition language. So this one, so we talked data manipulation language earlier where we do the inserts, the updates, and deletes. Well, actually, no, we're going to talk about that next.
We're going to talk about that next.
Yeah, we're going to do that next, sorry. So we did a DDL is a data definition. We're actually creating objects or altering objects or dropping objects. So it's the creates new objects, alters, modifies them, and drops or toasts any objects. And that's for database all the way down to views or stored procedures or anything like that. So the create statement, you saw it's used for database, table, default. Any of these can use the create statement. Here's that example that I supplied for you already. This is what I showed you for creating that database. and the table. Here's to create new table. And this is the one I demoed for you. I think I did the demo first, and now I'm showing you the content. That's pretty funny. Went in the wrong order. I was supposed to create the database just inside the GUI.
We were both
jump
pretty
out.
excited about actually creating
And I wanted to do
the
something.
database.
I wanted to do something with scripts or with queries. So this is what we just saw. If you look at it here, it's not all color coded and all that cool stuff, but it worked. You saw that it worked. And alter the statement. As you saw, I took the sales and changed it to sales forecast. And drop statement, whether it's a database or a table, view, role, whatever it is. It's simple. For DDL, it's create, alter, and drop. If you understand those three, that's the bulk of what you're going to need to understand for DDLs, when you're data definition language statements, to be able to manage the objects inside a SQL Server. So this is where I was supposed to do the demo that we just did. So I did a dual demo.
But this is where, let's go back and actually talk about the graphical user interface and scripts. Show me the cool feature in SQL Server here about how I can get a script.
You want a script here?
Yeah.
We can do that easy enough. So what we could do...
This is one of my favorite parts of SQL Server because you can kind of cheat. Because the lesson here is that there's a graphical user interface way to do things, and there's a script way to do things, but you don't actually need to memorize how these scripts are created because SQL Server has this great feature that Brian's going to show us.
Yeah, so the cool thing, what you're talking about is, I created this database using the GUI. Now, I didn't populate anything in there or anything yet, but what I could do is after I create an object using the graphical user interface, I can come in here, if I can grab it here, and I can go into script database as, and I can have it generate that create statement for me. So that create statement I use to create the sales database, I can take this in any object, whether it be a view, a store procedure, a table, and I can have it generate this by using the create to. Now the other thing is the drop and create to. This is kind of cool because what it does, it adds at the top of the script, it adds to it. Let me just go ahead and kick this off to the clipboard. Hopefully that'll open up for me. Let me do a file so I know I can find it. And we'll call this class demo. See, even down here I use the Pascal case script. All right, it's going to save it as a .sql file. Lost my mouse again. Come back. So I'll open that up for you just a few moments. In fact, what I'll do is I'll do it just 1 sec here. I'm going to go over here. I'm going to go into here, up into... Where did it save it?
It did not save it to the desktop. That's all I know. I didn't actually catch the path.
I always save it to the desktop because I'll lose it. So we're going to do it again.
I think you can just, when you go into the script database, can't you just do drop and create to a new query editor window and it'll just open it right up?
Yeah, okay, we'll just do it that way. I just wanted to show me you could save it out and I can ship it off.
And then you can save this file.
Yeah.
This is just a document system where you can save the SQL file.
Yeah, and this is cool because look at it did. I already said use master because it has to update this content in master database. This is another way for comments. Do a /* and then you close it out with a */ over here.
So let me just, because you just blew my mind again, I just want to make sure we talk through what just happened. Okay. You right-clicked on the database.
Correct.
You said drop and create into the new query window.
Right there.
Generate scripts, drop and create to, and then you said new query editor window. And SQL Server generated this whole file full of stuff that starts with the use, and then it says drop the database class DemoDB. So if you wanted to make changes to your database structure or say a table that you did, you could just use the generate script command.
Exactly.
You'd get a window like this. You could make the changes that you wanted, and then you could run the commands here to make the alter or modify or create changes that you wanted.
Yeah, maybe I don't like to, like you said, it's going to drop the database that's out. So you can run this multiple times. I create it, yep, not quite the way I want it. Create it, not to, and come back and change it. I don't like the location. I can change the location here and run it and create it again.
Got it.
Multiple times. And the cool thing is it's scripted. I can create it. I like it. It looks good. Pete likes it. I send it off to him. He can execute it inside of his SQL Server.
So I just kind of blew up your whole logic about getting paid by the hour and writing scripts because you just showed me how quick it is to generate a whole bunch of scripts that I can just go modify.
Yeah, so your manager's going to like that.
Right.
It's here I'm saying, my manager's going to be like, what, really?
I'm all about getting it done faster.
No, I am too, definitely. Yeah. And here's some other alter database statements. So it generates a bunch of items for you. These are all the parameters we're not going to worry about. But the idea is we can generate scripts. Again, that could have been a table. It could be a view. Anything that you have for objects. Right-click, generate script for. And there's often they'll have the drop. I always put the drop there. That way, in the event it already exists, it won't, because without that drop, if I tried to run this, it's going to blow up. Say the object already exists. So to avoid that, you can just actually go out and drop that.
The other thing I wanted to point out is I think this is a really great way to learn how SQL Server is doing things, because sometimes you can page through the graphical user interface to discover all the options, but you can also, if you like to read the script code, a lot of people are into the sort of programming aspect of databases, you can use this generate script command and actually get a big file of T-SQL.
Yeah.
And then you'll discover all kinds of features that SQL Server has as you parse through that script and see what's in there.
Yeah, good example of that too is if you want to write your first store procedure. Man, it's like I know Brian said you could pass parameters. There's a ton of store procedures coming out of the box. Right click, generate a script. You get that for a basis now, and you can use that for writing your own store procedures now. All right, so is that all I wanted to do in here?
Yep.
Okay, good.
Yep, I think it's about time to wrap up the module.
Yeah, I think
actually.
it is definitely. So let's see where we are.
We've covered a tremendous amount of ground in this module.
It's fun.
We went from fundamentals to suddenly we have our own database with a table. Granted, we didn't really create all of the details of the table just yet, but we're on our way to doing that.
Yeah. Yeah, so we got to talk about data types, what different ones there, how to create the database, both the SQL, SSMS, create, alter, and drop objects, Pascal case or camel case. Choose one of the two. All right, make sure that you do that. Don't leave it. Don't mix them up. You already know my preference. I won't go in there again.
You know what we should do before we wrap is we should talk through. Let's just go back to the original example that we use. Let's go to the. You want to use the grocery store one or the CD library one?
I like the CD library one.
So the album one, we started with the spreadsheet, my giant spreadsheet of all of the records.
Right.
And then we did some normalization on that. We decided that we were going to start with 3 tables: an albums table, an artist table, and a genre table.
Right.
And what we learned in this module is that to really actually create those tables, we need data types for those things.
Right.
Right? And then let's just talk through the album one. If it has an album ID as a primary key, then what would you think a data type would be for that?
That would probably be an integer.
An integer, because we know that integer goes up to
32,767.
32,000.
32,000-ish.
So for my database that has a few, let's say 100 albums in it, that's probably a limit that's appropriate. So I'd make a choice for the data type for my primary key, because I don't think I'll ever go over 32,000 albums in that list.
Yeah, might even actually. I think that's a tiny int. This is tiny int, there's small int, and integers like huge.
And the point is,
number.
You'll think about the data types that you have, and you'll think about the data that you're going to put into that table, and you'll make an appropriate data type decision based on the data that's going to be in that table. So album name, we'd need to decide what we think the longest possible name of an album is, and then make a data type decision based on the data. So this is more of that data modeling stuff. We're not going to give you lots of guidance about how to do that, but these are the kinds of questions that you'll have to think about when you're actually creating. You'll have to first understand your data, and then understand that there are data types to make choices about. Then when you create the table, you'll be able to make a smart choice about what data type to use for those things. So I just wanted to kind of reiterate that's how we hooked it together from the first couple of modules to now what we've just learned about. We create the database, we know it's going to have a bunch of tables. The tables are going to have these data types, these fields with different data types that are appropriate for the data that's in them.
Right, exactly. And then the next module, we're going to look at some of the awesome commands that we had to be able to go and actually grab this data and slice and dice the information. So, all right, so this wraps up on creating the database and the objects. We're going to look forward to taking a peek at the how we manage that data down.
Let's do it.
Okay.
Thanks. Welcome back to Database Fundamentals. This is Module 4. We're up to Module 4.
I know, definitely.
Yeah, it's gone by really quickly.
It is.
Yeah, but it's been fun. We started out with kind of the very conceptual Module 1, where we looked at some of the core concepts to creating a database, or to databases and why we needed them. We started with our big spreadsheet. In Module 2, we talked about relational concepts like normalization and referential integrity. And we just got out of the module 3 where we learned how to actually create databases and create tables. And that was something that we called DDL, Data Definition Language.
Nice. Yeah, exactly.
And now here we are in module 4, which is, it even has DML in the title, which is Data Manipulation Language.
Correct.
Is that right? Manipulation Language? I always
Sounds
get
good to me.
confused about these acronyms,
Yeah.
DML and DDL and DCL, which we're going to look at later. But in this module, we're going to actually take a look at finally using data. We're going to take a look at, we're going to start, I think, with how you actually use the select statement, which is kind of the bread and butter of querying a database. And then we're going to talk about some of the other DML statements for doing inserts. We'll actually look at how we got the data into the database in the first place and how to do updates and deletes as well. But take it away. I can't wait. This is probably the big module for the course, and I know that you've got all sorts of cool demos for us.
Yeah, the cool thing about this is we talked about the importance of data types and being able, like we've been saying, the Excel spreadsheet was nice if you had just a few rows. You weren't worried about slicing and dicing your data. But if you get it into these tables inside the database and with these relationships defined, this is where you can really, the magic happens by being able to use the select statement. It's that simple. It's really using a DML select statement. So we're going to talk about that here. Specifically, we're going to start talking about the select, and then we're going to talk insert, update, and delete real briefly there. Let's skip a few slides at you. So select statement, here we go here. With this, it's used to retrieve rows and columns from a table. I showed you the most basic select statement there is. Select asterisk, which means all columns, from, and whatever table name. That's as easy as it gets. So with that said, though, you may not want all columns. You may want specific columns. That's what we're going to do. Is we're going to introduce different ways for us to really start slicing and dicing the information. Because right now, if I do a select asterisk from a table name, to me, I'm doing what I call a table dump. I'm just dumping every row and every column, and so I might as well have a spreadsheet. It's not quite that bad, but what this does now, I've got choices. I can choose what columns I want to display, and I can choose what rows I want to display. Columns are chosen by, instead of doing a select asterisk, you specify the column names. Instead of not supplying a where clause, you supply a where clause, and that introduces what the criteria is on those rows that has to be met for those rows. So now you're narrowing your results down both in width and in height, because now we're getting only certain columns and only certain rows because of what we supplied. This is an example of it's still a fairly simple select statement, but now we've taken it down and we've supplied 3 column names instead of the asterisk. And instead of dumping everything out from the employee table, we said where business entity ID is less than or equal 50. So we're actually supplying a where clause that's saying I want to see everything from 1 to 50. Where business entity is 1 to 50. And this is what I want to see. I want to see job title, and I want to see gender. So that's what we're doing. We're specifying the actual columns, and we're specifying the rows. The rows are driven by the where clause. The columns are specified right after the select clause as to what columns that you want to see. So this is taken from a simple select statement to, now I'm getting a little bit more picky about what I want returned to me. I can get pickier. I can add multiple criteria to the where clause. So notice here now, I'm still doing a select on these 3 options: business entity ID, job title, and vacation hours now. From the table, still have that. Now my where clause, where job title equal designer engineer, and oh, by the way, gender has to equal F, and oh, by the way, their hire date has to be greater than or equal to January 1st of 2000. So now I'm really narrowing down what's returned to me in my result set. I'm specifying 3 bits of criteria. They all have to, each record that's going to be returned has to meet. They have to be a design engineer, they have to be gender female, and they have to have been hired later than January 1st of 2000. So I'm getting very specific. Can you do that in Excel?
I can't. I was actually just thinking.
I can't. I'm no Excel guru, but I'm pretty sure you can't even do this.
No,
with that.
And what's awesome is that right away here in Module 4, you've solved the thing that I was wondering about all the way back with my spreadsheet, which is how am I going to figure out how many jazz albums I have,
Exactly. Yeah.
right? Or which are the jazz albums in my collection? And you just showed me with this criteria, this where clause on the select statement with all the referential integrity that we've got. I just need to reference where genre equals jazz, and I'm going to get just those jazz records out of my
or your disco. I know you keep talking jazz, but I still think you got
it's a very small
you got a
list
slew
of disco
discos.
records. Don't knock disco as an
I think it's
important
good
genre.
stuff. There was a good time for that. So the next one, instead of using an and clause, we're using an or clause here.
Yeah.
select business identity, entity job title vacation hours from the same table, where vacation hours is greater than 80, or, so it could be anybody has more than 80 hours available to them, or their business entity ID is less than 50. So pretty much I'm going to get everybody 1 through 50. And then anybody else that has more vacation hours than 80 hours are also going to be displayed. So now I've increased the number of rows in comparison to the other one. So my AND clause is it has to meet all 3 criteria. My OR says it's going to meet either of these criteria, and I'll get that returned to me. Okay. By the way, I'm going to demo all these for you. We're just going to walk through them so you understand what they're all about, but we'll see these all in action in just a little bit. The between clause. Instead of specifying the ands, or if I want to specify between a certain date range or between a certain, in this case here, vacation hours, very, very similar syntax. Select the column names from the employee table where vacation hours is between 75 and 100. Now I could have done this a different. I could have said where vacation hours is greater than or equal to 75 and vacation hours is less than and equal to 100. That would have worked, but this is a between. This makes it a little bit simpler. So now I'm going to say if the vacation hours are between 75 and 100, I want to see those rows. So it's just another way for us to massage or slice and dice the data as it's being displayed. Now the bad thing is right now is we're getting data dumped out to us, but we might want some sort of order to it. What we're going to do now is sort the result set using the order by clause. So what we're going to do is we're going to take the same content, with the same command we had in a previous slide, select business ID, job title, and vacation hours from employees, where vacation hours between 75 and 100, and order the vacation hours, order the content that's displayed to me by vacation hours. So the default is ascending. So anybody who has 75 hours is going to show up first on the list, 76, 77, all the way down to 100. So I'm going to actually specify how I want that content returned to me. You can reverse that. I used the same exact command on the bottom of the slide here. And on the reverse of it, all I did is I added this DESC, short for descending. So now instead of seeing 75 at the top of the display down to 100, I'm going to flip that and see 100 down to 75. So it gives me an opportunity to sort and decide what order I want to sort them. And it doesn't have to be vacation hours. It could be by date. It could be by alphabetically. We can choose what column that we want to order that by. So now we're getting some more. We're getting some order, no pun intended, to how the content's displayed to me. It's not just dumping the data out because it met the criteria. We're telling it how we want to see that data displayed to us using this order by clause. So it gives us a little bit more control of how that content is displayed. So that's saying how we want to grab content. What if there's content we don't want to see? We've got the not clause. So what this is, I'm going to grab this 3 items, business entity ID, job title, and gender for columns, from the employee table, where not gender equal M. It's kind of weird when you say it, where not gender, but where not gender equal M. So when I run that, I should only see gender equal F, because I don't want to see, I'm telling it, I don't want to see gender equal M's, I just want to see items where. Now I could have expanded on this. I could have said where not gender equal M and title equal design engineer, or something like that. So again, I can expand on some of these commands more so than what we're showing here. I'm just showing you different flavors and the power of relational tables in a database that we didn't have in our spreadsheet, because now we have control over what data we want to see, how we want to see it, what data we don't want to see. And I really want to be more restrictive on, I want my disco CDs that's got Celebrate on it or something like that from a certain artist. Do you have that one? I'm just curious. It was just curious.
You're bound and determined to get me to disclose which disco albums are in my collection.
Yeah, no, we'll find out. We got a little time. Okay, the union clause. What if I have content that's in 2 different tables? Yeah, we can do that. So right now what we've been looking at is all right, you're telling me I can grab content from a table. What about if I have content from 2 tables? Well, this is what I can do here. As long as the columns are matched, so as it says up here, it allows you to combine the rows, return from multiple select statements into a single result set. So we're doing select business entity ID, job title, and hire date. We're selecting that from the employee table, where we're still supplying a job title, where clause, where job title equal design engineer. Now we want to union that. I don't want to use the word merge because there's an actual statement merge. We're going to take that content and we're going to have content from the second select statement. Again, the columns have to match business entity ID, job title, hire date, from the employee table, where hire date between 2005 January 1st of 2005 and December 31st of 31. December 31st, 2005. These dates are weird for me. I'm not used to having the year first. So now we're going to union. We're going to take two select statements. We're going to populate the content into one result set, but there's actually criteria from two different statements, and we're going to return the same column. So we'll see how we can have a statement that returns columns based on pretty much two separate where clauses and two separate select statements. This could be a different table. If I could go out and do select business entity ID, job title, hire date from human resources dot X employees, if I wanted to, where hire date or fire date was a certain date. You can do that as well. As long as the columns match up, you can retrieve that content from different tables here. So this is the union clause, and again, we'll see how that operates for us here. The except and the intersect clause. So the except clause returns distinct values. Distinct means unique in the sense that I don't want any repetitive data. So now I'm saying, okay, so if I did a search, I want to do a search of my CDs where genre equals disco, and I've got the same artist. I may not want to see the same artist. I want to see all my disco albums, and I think that's probably 100-ish that you have.
It's at least 100.
It's at least 100. So anyway, but I don't want to see the same artist each time. So I want distinct. I want unique artists that with the genre of disco. So what I do is select product ID from the product table, except, and then select product ID from production.work order. So it's going to return both of them for me. All right, but anything that's matched, it's not going to return that. So it's not going to return anything. That's a match. It's going to just do the distinct items. The intersect clause down here returns any distinct values returned by both the query on the left and on the right. So what this one's going to do, the left being the first query, by the way, they term it as left and right. It's the first query. It's left of the intersect statement. Let's put it that way. So this is going to say returned. So the first one up top, let me go back there. From the left query that are not found in the right query. So the except is return distinct values from the products table that are not found in the work order table. This one down here says return by both the individual information, distinct values again, not everything, but distinct, by both information that's distinct in the left and the right sides of the intersect operand. So anything that's distinct in product and work order will show up in that second one. All right. And again, I'll show you a result set of that as well. But it's just ways for me to be able to slice and dice that content that we just were impossible to do with 1,000 or so rows in a spreadsheet. But by being able to create relational tables inside a database, we're able to manage that data much easier. The join clause is it's a little bit more advanced. We're just going to introduce the concept of a join here. There's a few different flavors of joins, but it allows me to use content from two different tables. So an inner join uses a comparison operator to match rows from two tables based on a value that exists in both tables. So product ID, we'll go to product ID. I could go to do a join, a product ID from one table, and do a search or select on a product ID from another table. And with an inner join, it's going to look for matches on that product ID and give me that content. Okay, so it's a match. Outer joins, if it's a left outer join versus a right versus a full, but if it's a left outer join, it's going to include rows from one or both tables, even if they don't have matching values. So if it's a left outer join, it's going to give me everything in that first table. All right, we'll say it's a product from the products table, and then any match from that second table. So that's what it'll do for that. So if it was a right outer join, it'd be everything from the right table and only the matches from the left table. Cross joins is also, I think this is also, no, the cross join is going to return all rows from the left table and all rows from the right table. So it's pretty much a table dump for both of them, unless you supply a where clause. If you supply a where clause, then it'll narrow down what's being returned. Otherwise, give me everything from the left table, give me everything from the right table. It's kind of a good way to generate a bunch of content into a temporary table, and you can use that for testing content or testing other statements that you want, because you want to generate 30, 40,000 rows of content. So joins allow you to combine related data from multiple tables, and we're going to kind of leave it at that. It's more of an advanced topic, but just want to let you know, because we're creating multiple tables, doesn't mean I can't grab data from multiple tables. I can certainly do that, and do that using one of these different types of joins that we can look at in you can maybe experiment with.
This seems like it's a great opportunity to plug another Microsoft Virtual Academy session that you're doing. We're actually recording it tomorrow. That's a whole session about the T-SQL querying language that you're doing with Tobias Turnstrom.
Yes.
That's going to go really deep into these topics. So keep your eye out for more content on Microsoft Virtual Academy if you want to go deep on the querying.
Yeah, so some of these that we're just doing the high-level approach on the fundamentals. This is querying SQL Server, querying Microsoft SQL Server 2012. That's going to be recorded. It'll be out shortly on Virtual Academy, and you'll be able to review that with Tobias and I. So great point. Thanks for bringing that up and reminding me of that.
Because you kind of blew my mind with joins are complicated on their own, and then you went into inner joins and outer joins, and it gets super complicated. For the purpose of my CD library, it's way out of scope.
Yeah.
But I can see where I'm going to want to go get more information about that when I start like hooking up to the Xbox Live Music service and
there you go.
figuring out which music I have that's also on the streaming service, things like that. Once I get really into my application that I'm going to build.
Yeah. I'm waiting for the
Monday.
I'm going to be your tester on that.
That's right.
Yeah, you send me an SQL. Run this. This is an example of what are called aggregates. And so what we've done here is I don't want all the tables. I need some average information. I need some information that's aggregated. So what this does is provides you summary of data. So this example does a select count distinct sales order as unique orders. So what this as does is just gives it a different column header. Just want to throw that ID in there for you. So select count, so it's just going to do a count of all distinct sales order ID. So if I got a sales order ID of 1, 2, 3, it's only going to count, and I got 10 line items in that, it's only going to count it once. That's that unique sales order ID. Then, by the way, for that sales order, I want the average unit price. Not for that sales order. In addition to that sales order, the sales orders, I want an average unit price. I want to know the minimum order quantity that was ordered in any of the items in that sales order detail table. And I want to know the max line total. So what's the maximum amount one item or one line item was charged? What was the maximum amount, what sale on one line item? So this is taking content, instead of dumping all the detail out, it's actually providing you a summarization of this content and showing you how this content would be displayed and what your min or what your at max and what your average was and what the total number of records are for a particular sales order ID. So again, I will demonstrate that for you so you have an idea as to what that looks like. Those are really, really powerful. For instance, Pete may want to go in and say, well, how many disco CDs do I have, or albums? I'm trying to call them albums. He could go in, he could do a count where he could do select, count, distinct, from the genre, that'd be where it would be, and where name equal disco. And so it would give him a total number of items. No, actually, we wouldn't do it in that table. We'd have to do it in actually the album table.
Do it in albums.
Albums table, yeah.
Select the distinct count.
Yeah. And then we give him all the disco albums. So then we truly know how many disco albums he has. Definitely. Because he doesn't want to tell us. But we'll see that one in action just a little bit here. How about right now, in fact?
I'm pretty sure for Christmas you're going to get me the complete works of Donna Summer anyway, and then the whole
Well, I wasn't sure what I was going to do now, but I don't know. Disco Gone Wild.
I might already have that.
Oh. Well, let me know so I don't buy it again for you. Because I'd hate to do that. Okay, let's go back into Management Studio here. SSMS, I'm over on my desktop here. I'm going to open up another query item, query file.
All the students really wish that you had my CD library data for all of these
oh,
samples.
Yeah. All of them are going to go find out, like, who did celebrate?
Sadly, I think we're going to use AdventureWorks now, aren't we? Is that where the
No,
demo?
we're still, I'm sorry, we're staying with AdventureWorks.
We're going to stick with AdventureWorks. So can you just give me a quick overview one more time for the people who are just joining us?
Yes.
AdventureWorks, tell me about the data, because I think the samples we've been using make a lot of sense because it's pretty easy to wrap your head around a music library or around a grocery store. But what's AdventureWorks and what kind of data is in there before we get too deep into these samples?
That's great. So AdventureWorks is a sample database that's provided that you can download and install if you want to test this in your SQL Server world. And it provides us sample data. And as you can see here, I'm just going to open up the tables. It's got human resources, got employee, department. So they've already done the normalization. They've already done all the relationships for you. It's got an entire area, 246, just in human resources, a dozen or so on person. Notice they have a person address that's separate than address type. They have a contact type. They have a password, They have a person, and then they have person phones. Then they have the person phone type. I mean, they've really normalized this data to the nth degree. And then the production, all this information about production category or product category, product photo, product photo. Not quite sure what that would be. Product reviews, scrap reasons they got rid of content or a product. And then we've got purchasing information. All right, we've got product vendor, vendor order detail, vendor order header. I mean, it's just all been totally normalized, and there's, as you can see, dozens and dozens of tables in here.
It's interesting because AdventureWorks is a huge enterprise database, and the hypothetical company AdventureWorks sells sort of adventure products, but they have data in their database that manage the business of running AdventureWorks, so all the people and HR stuff.
Yeah.
But it's also got the product catalog and things like that.
Purchasing, sales.
And all of the sales, and it's all in that one database, which is how they chose to do the structure. And we can say that AdventureWorks is a little bit contrived so that it makes a really concise sample that people can use.
Right.
But there's lots and lots of data in there, split up into a variety of different sort of business data that we're going to use in the sample.
And so we had just had someone chat into us and say that the longest album title ever is 89 words long. Words. I thought it would be characters.
89 words. We would need a full
I have to
character
find that.
count.
Yeah, I have to. I mean, I would know. We have to figure out the character
The
count.
average length of the words.
Just
I don't
to
think we have enough information really.
Yeah,
to
not enough to
figure
make
out
a
what to
decision on
do
how
with-
we create that field.
with
But it's
that.
information like that. You'd be surprised. The 89 words, I would have never guessed that, without a doubt.
So if the AdventureWorks product catalog had album titles in it, then the product name field would need a data type to accommodate an 89-word name.
Yes, exactly.
Got
So it's
it.
stuff like that you have to think about while you're actually designing your database, because I would have never guessed that. I'd have probably gone 50, 60 characters, 100 max. I would have gone 100 max of that, just off the cuff. And now I'm thinking, that's not anywhere near enough. So, well, thanks for chatting that in. That was great information. So now, if you could find out who did Celebrates, because Pete won't tell us, that would be awesome. Cool in the Gang. Wow, that was quick. That one came in. Somebody's got that in their collection. Okay. All right. AdventureWorks. Module 4. We're back in AdventureWorks. Thanks for reminding us to kind of just show what it looks like in case someone joined us here a little bit later on. We talked about this table dump. Remember, this is pretty straightforward. We do a select asterisk, and again, this is all scripted, so I can just not cut and paste. I can highlight. Actually, notice up here I'm in the wrong interface or database. So I'm going to grab Use AdventureWorks. Remember, I try to get in the habit of just using or supplying the Use AdventureWorks only so I know that I'm always in the right database. You saw a couple times doing a demo, it didn't work. It's like, oh, wrong database. So if you can include that in most of your statements, especially if you're bebopping between a couple different databases, it'll be helpful for you. So let's do our basic statement. We're going to go ahead and execute this baby. And you're going to see we got pretty much a table dump. We got business entity, national ID, and I'll scroll over here. Trying to get you dizzy, I'll scroll slower. And this is pretty much everything there. Notice there's 290 rows. If you can see way down the bottom, there's 290 rows that were retrieved from that table called employee. All right? And you can see, you saw all the columns as I scrolled from the left to the right, and I'm going to scroll back. So we just pretty much did a data dump. Now again, you've seen all these slides. So all these slides are, now we're going to show you how these slides that contain the text on the statements on there. Now we're going to show you how they work. So then we went from the table dump to say, now let's decide what columns we want and how we're going to throw a where clause in there. So we're going to execute that one now. So now we're going to see business entity ID of equal 50 or less in 3 columns instead of all of these columns. So we'll execute this one. Here's our business entity ID, here's our job title, and here's our gender. Now if we scroll down, we should see business entity ID 1 through 50. And I just hit bottom, and you'll see over here, whoops, 50 rows. And we just got important information into us, 360 characters for that 89-word title. So we would have to have a varchar, because that's going to be huge compared to everything else, of 360 characters. I mean, who'd have thunk? I'd have been 100 max.
I had no idea.
Yeah, and celebrate that. All right, so that's cool. Now we've narrowed down the rows and the columns. Let's go in here with our multiple where clauses. this back down a little bit here. This is where we got the same, we had two columns here, a third one of vacation hours. From the employee table now, still, job title equal design engineer and gender equal F, and hire date is greater than January 1st, 2000. So let's see what kind of content this will return to us. And like I said, it's okay if you highlight the comment, it's just going to ignore that anyway. And you'll see we have two people who meets the criteria that are design engineers, have vacation hours of, what did we just say? Oh, we didn't care about that. A business entity is 5, and that was supposed to be, I could have changed this one a little bit.
Well, the where clause is showing you what you got back. We just didn't include the columns in the where clause, and that's pretty interesting as queries go.
Yeah, because
we can assume, since we have and gender equals F, that everybody there has F. So we didn't really need to return it as a row in the query, or as a column.
What we could do is
query.
let's do what's on the fly here. Let's change this to hire date, and let's change it to
sneaky
gender.
You want to see it anyway, just to prove that your query works?
Yes. Gender. Okay, business entity ID. No, we want job title. We don't care about this. Let's get this guy out of here. And we'll get job title. All right, let's try to run this baby again. So job title is design engineer, gender is female, and hired on 2/6 and 2/6 of 2002.
Right, and we would have kept the employee ID in there just so that we could figure out who they were, so that we could go and use that information in our application.
Exactly.
Yeah.
There we go. So we can find out who they were.
Because that's the key in the employee table.
That is. Now, how do I find out their name? This is where it would be helpful for me to now, remember this is going to be a primary key called business entity ID somewhere out there, and we can probably go see it real quickly. Tables. Under human resources, we're coming from employee. We'll probably maybe person.
Why don't we go look at the fields that are in the employee table to see
person. Person.person. So I would map that business entity ID.
But hang on a minute. You're jumping ahead, though. All we're doing is we're looking in the employee table. How do we know it's not there?
Oh, I thought I just showed you that. If we open that right
Let's
there.
just reiterate.
Here is the employee table.
So I want to just stress the foreign key that you're implying here.
Okay.
Right?
So here's this
guy
here.
There is nothing in here. There's job title, but the name of the person is not there.
Right.
So how do we get from there to person?
So we get there from there to the person. We get into one of those joins, and then that would map to, and we won't get into that, that would use that business entity ID.
The business entity ID.
That would map to this guy over here for this 5 and 15.
Got it.
And we could grab the first name and last name from there as well.
Got it.
Nice.
So it's both the primary key and has a foreign key relationship to the other table.
Yeah.
Got it.
Yeah. Cool stuff. All right, so we got creative with that one. On the fly is good most of the time. We'll do this one now. This is that multiple where parameters with the or. So this is the and. So this is where we want vacation hours is greater than 80 or business entity ID is less than 50. So now we're just kind of deciding. I forgot one of this thinks it's a. There we go. I forgot one of the little dashes. So now we've got these folks here: business entity ID, job title. What we're looking for: vacation hours greater than 80. Or business entity ID is less than 50. So notice this one here doesn't meet the criteria of vacation hours is greater than 80, but the business entity ID is less than 50. So we still get that returned to us. Now I thought, did I do it the other way? Yeah. Here's a between. Oh yeah, that's later. So here's the between clause that we talked about. Now we want vacation hours between 75 and 100. So this met two different criteria. We got rows returned to us. This is going to say we're going to get the same content. We're going to get content returned to us where vacation hours is between 75 and 100.
So these are the people that need to go on vacation before they lose.
I don't know why I'm not listed in here.
Hours.
I should have a vacation. So notice we have 99, 80, 82, 79, 98. But there's no order. I mean, the only thing, by default, it kind of dumped it out by business entity ID. But that's just, you you can't count on that. I mean, it may do it pretty consistently, but if you really want it to be displayed in a certain order, you're going to want to use the order by option. So I'm going to use that same command I just used up here, but I'm going to order it by vacation hours instead. And by default, it's going to be ascending. So I'm going to run that. See now, instead of sorting it by business entity ID, it's sorting it by 75 vacation hours, 78, 79, 86, all the way down up to 99 vacation hours. So now I'm controlling how the content's being sorted. Remember I said we could go in reverse order or descending? I'm taking the same exact command. I'm adding the DESC on the end of it for descending, and I'll execute it. Now the 99 start up at the top, and they go down to the 70s in the bottom if I scroll down. All right, so we can control that, and it tells you how many rows, by the way. If you're not quite sure, there's always down here, it tells you the number of rows. If you quickly jump over here, it tells you how many rows. So if you're curious in some of these commands, like how many rows did that affect, jump over to the messages, or if you happen to peek at it, it happens to be down on the right-hand side. It'll show you how many rows are affected. And there's some commands coming up, I think. We're going to hit thousands that might work, so it'd be good to know. All right, using the not clause. We showed you this. This is where I want to see anybody where their gender is not male from the employee table. We'll execute that. So they have 84 rows from the employee table. And then we're going to go in and we're going to do a union. This is where we can get content from two different tables or two different options. So we're going to combine data from multiple tables. It's actually the same table, but we're going to do this. We're going to get business entity, job title, and hire date, same as down here. It's two different select statements with a union in the middle. From the employee table, where job title equal a design engineer, and hire date between 2005, January 1st, 2005 and January 31st, 2005. Now, what's a way we could have done that differently? Did I really need to use a union? I could have with a where job title equal design engineer. I'm trying to do a union. Or hire date between 2005, 1/1/2005, 12/31/2005. I could have done that in a single statement. Unions are probably a little bit more powerful if you go two different tables. It's difficult to find two tables that have repetitive columns in them, though. You might have a choice. You might have like an employee who happens to be a customer, so they're in there as first name, last name, maybe city. But it's sometimes difficult if you've done all the normalization to find columns that are that don't match the actual data, the values in there, but that match the columns required. In this case here, business entity ID, job title, hire date. Or let's use first name, last name, and city. I could probably find that in a couple different tables and then just join those that way as well. Here's the returning distinct values from the left query not found in the right query. And we'll execute this one. So product ID, so it searched product table and it searched a work order table, and it found 266 rows. Let me click this guy here. That had unique values in them between the two tables. All right, and I could have added more information as far as what table it came from and other information about the product, maybe description, but just to show you that we can grab. This is going to be the intersect versus the except. This should be bigger. So we're going to highlight that. We're doing the same thing, but we swapped out except for intersect. And we got 238 rows actually. So let's see, distinct values returned by both queries. What was this one back here? Oh, these are ones not found. So these are really just turned in from one query, and these are from both queries. You think there'd been more in that one? What was this one? Let me run this one again.
This is an example, because I'm not familiar with the work order data, that when you're looking at the results, the only real way to know if it's working is if you really have a fundamental understanding of the data that's in those tables, so that you can logically deduce if you're getting results that make sense.
Yeah. Yeah, that data modeling part you were talking about.
That's right.
Understanding the data types, why they're there, what to expect from those data types. So exactly, this is the adventure works unless you've studied it.
And if you're writing the query and you don't know, then you have to go find the person who owns the data that's in there to say, this is what I got, but is this what you expected or not?
What should I expect from here?
Right.
Yeah, perfect. Here's my aggregate function sample. We've got the count of distinct sales orders, unit price, order quantity, average unit price, sorry, minimum order quantity, and maximum line total. So we're going to go ahead and run that. It's all aggregate functions. So we're going to get one line. Unique orders, 31,465. Average unit price is $465 and some odd. Minimum order quantity is 1. I would hope so, otherwise it wouldn't be an order. And the maximum line total on one of all the items in the sales order detail is 27,893.
So hang on, let's dig into this for 1 second. You did a select count of distinct sale orders, and you added a bunch of aggregate functions.
Right.
So basically in one T-SQL statement that is 1, 2, 3, 5 lines of code, you summarize all of the sales in my system.
Yeah, try that in Excel.
That's pretty amazing.
It's really cool. I mean, I know right now that the average price, what do we have? We have, these are unique orders. Let me just do
31,000 orders.
That's unique orders. Let's take this baby out. Let's just grab every order. So let's take that and run that now. Now it's 121,000 orders.
And the average unit price of each order, of the orders.
All of the 121,370 was $465. I don't know what they're selling, but I like it. And still the max, that's not going to change. This probably changed because we have more rows in there.
Yep.
But so again, just removing distinct dropped it, was it 38,000 rows?
Something like
brought
that.
up to 120,000 rows just by removing that one clause. So that distinct clause is really, really important. I just want to show, okay, so what we're going to do now, this is inserting data. What we're going to do now is go back to PowerPoint is what we're going to do. So I don't get too demo happy again. Oh, I keep doing that. I'll let this guy come down here. All right, let's go back in. So those are select statements. So some of the stuff we just showed you would be impossible to do with Excel. And it's just all we had to do is it's the upfront work. It's the data modeling. It's setting up the relationships. Once you have that done, it's just so much easier for you to slice and dice the data. So that's the select statement. That's just a piece of the select statement that we're looking at here. So and there's more. Again, that querying SQL Server, Microsoft SQL Server 2012 class. We're going to dig much deeper in those joins and a bunch of other items tomorrow, or when we record that. All right, we need to add data. So in order to add data, we can use the insert statement. So we do an insert into, and then we supply the table name, all right, in the schema. The values, all right, so I'm going to add into, now notice I'm not supplying any columns. I'm going to just say, if I know this, if I understand the columns that are in there, I don't need to put the column names in there. So I'm going to say insert into production.unit measure. Value of the first field is going to be FT. The second field is going to be feet, and the third field is going to be a date, okay? Now, what this is going to do, and again, I'll go back out and execute this, it's going to add a row into the unit measure. Now, if I want to add 3 rows, I could go in something similar, insert into production.unit measure. Here's the first one. I thought I changed, I changed it in the script. And here's another one, so I'm adding square feet. I'm adding square, trying to change it, I can't do that. I'm going to add yards, and I'm going to add cubic yards. My script is slightly different, so when I go out and show you that, this is going to be slightly different. I changed it because I wanted to show you something. Because right now, I'm hard coding a date. That's really kind of unrealistic. What I'm going to show you in the script is, why don't I just throw in today's date? So I'm going to change, I changed this a little bit, so it's going to actually go out, retrieve the system date, and populate that instead of this hard-coded date. So that's how I can add content. Insert into either an individual row or multiple rows using insert into. If I have a flat file, just a file, a TXT file, for instance, and I want to add content from that, I can use what's called a bulk insert. And there's a specified format, specific format you need to use. But I'm just thinking, what if you have an Excel spreadsheet, you dump it out to a flat file with comma delimited, can I get that into SQL Server? You can. And the easiest ways to do that is to help SQL Server understand the format of how that data is stored in the text file, using a format file, and then using a bulk insert command. It'll take all the rows in that file, flat file, and move them into a table. That's all I want to say about that, but it's another way to add a bunch of data, or if you've exported data from somewhere else, you need to get it into SQL Server, that's going to be your choice for doing so. It'd be a lot faster. Again, unless you get paid by the hour, where you want to do individual insert intos, go ahead and do it that way, but a bulk insert would be much more efficient. All right, the update statement. We're going to update salesperson. Again, I changed this query slightly to stay with our theme, what we were working with. But update, you specify the table. Set is the key word here. Set bonus equals 6,000, commission percentage equal 10, and sales quota equal no. So what this would do, it would set those values on those three fields where sales.salesperson.business entity equal 289. That's a huge problem if you don't put a where clause on an update statement. If that where clause wasn't there, what would happen just now?
Everybody would have gotten a bonus.
Everybody would have gotten a $6,000 bonus, a commission rate of 10%, and a sales quota would have been set to null. That means they don't really have to work. That to me was what I call an RPE. Anybody heard of an RPE? And I teach the admin class for SharePoint and SQL Server. An RPE is a resume producing event. We want to avoid resume producing events. I think everybody getting a $6,000 bonus, executing this command without a where clause could be an RPE. So we want to be careful with those. All right, delete statement. Delete from the table where production.unitmeasure.name equal feet. Again, if I did a delete from without a where clause, what did I just do?
Deleted everything in the table.
Wrong. I toasted everything in the table because I want to use the toast command. But yes, you're right. I deleted everything in the table. So when using updates and deletes, where clauses, is that a word? I don't know. They're essential because you can really mess up the data if you don't do that, if you don't supply a where clause. A delete statement without a where clause will cause all rows to be deleted. That's my point I'm making there. And I got slightly different commands in the query. Is there anything on this? It's okay. Okay, so let's go take a look at this now. Let's go back into these statements here. And we're going to pick up where we left off. First off, I want you to see what we have for information in the unit measure. So I'm just going to query that, kind of do a table dump. And what I want you to notice is that we don't have anything in there for F2, got an F3, but no square foot, square feet, cubic foot, no square miles. All right, so nothing in there for miles for M3. So I just want to show you that. Now what we're going to do is we're going to insert a row of information. And I'm going to insert this one. And notice what I also do differently. Instead of hard coding the date, I'm going to insert into this unit measure FT, N feet, and then get date. It's going to populate today's date in there instead of a hard-coded date. So I'm going to execute that. One row is affected. I'll go back and query that table in just a moment. Remember, I could do multiple statements. So here's that one. FT2. So remember, FT now should be in there. FT2, M2, and Y2 are being added. Now notice, I intentionally called this square foot. In case you're thinking, like, dude, don't you know how to talk? That's on purpose. And I'm going to execute that. 3 rows affected. Let's go back and query that. All right, we're going to F5 this. Now we're going to look for our FT and our FT2. Just scroll down here. Here's my FT I just added. Here's my FT2 with a square foot I added on purpose. That was wrong. Why did I do that? Because I want to show you the update statement. We're going to change. We're going to do update product.measure or production.unitMeasure. We're going to set name to square feet. Name is right here instead of foot. Where production unitMeasure.unitMeasure code equal FT2. So this dude right here should end up with square feet. So we're going to execute this guy. All right, 1 row affected. And then we're going to go back and execute this command to find out what's out there. See if we have a square feet instead of a square foot. We'll go down to FT2. And notice now it updated just that one column. Again, without this where clause, every item in here would have been square feet. So we got to be careful about that. We can delete a row. Delete from. Again, we need that where clause. We're going to delete the FT. You'll see it's right there. Simple statement, delete from the table. And then you specify the criteria. Execute that. We'll query, see if FT is gone. And you'll see that FT should be gone here. And you'll also see, so I didn't point that out to you the first time, FT is gone. You'll see now that square feet has today's date instead of that 2008 hard-coded date. It actually went out and grabbed the system date and time and populated that for us. All right, so that's the DML statements other than the select statement. That's the other items. Inserting, just a brief introduction to inserting, updating, and deleting content inside of SQL Server. We got just a couple more items that we're going to introduce. We're not going to go in depth on these, but these are indexes and triggers. I briefly mentioned the triggers already. Indexes, we talked about, we have either clustered or non-clustered index. The big thing about those is you can only have one clustered index. Indexes are very powerful. Notice the first line. Allow you to speed up the retrieval of data stored within a table or view. Okay, that's the primary reason we add an index, is to speed up the retrieval. There's a bit of overhead involved with inserting content if you have indexes turned on, especially a clustered index, because it physically sorts. If I have a clustered index on the last name, every time I add another last name in there, it's going to shuffle that data around to make sure it's alphabetized. Or if it's an ID, it fits in that ID in that row. So they're used to speed up your retrieval of content. We'll just leave it at that. We have clustered index, we have non-clustered index. You can only have one clustered index because the data can only be stored one way physically in one order. And we have any number of several non-clustered indexes. And remember I talked about the unique index. If you're looking for uniqueness on columns, you want to enforce uniqueness. The primary keys, you can only have one per table. Your unique index would provide you that functionality. Creating a trigger. Triggers are used to enforce a business rule. And then we'll just wrap this up. I got one more quick little demo on the trigger so you know what that does. So you don't think I'm just making up that word.
It's not the name of your horse.
No, Roy wouldn't let me. Was it Roy? Roy Rogers? Was that trigger?
Whose horse was Trigger? Roy Rogers.
Was Roy Rogers. Look at how old I am, huh? Okay, so we got this content here. All this trigger is doing is called insert success. This isn't doing much except for I just wanted to show you what a trigger does. This is a DML trigger. This is saying whenever anything gets inserted into the unit measure, it's called raise an error, even though it's not an error. That's just the term they use. It's called raise an error, and it's just saying, I just want to get a quick little message saying this was added. Remember, this could be something like, hey, when you do insert an item here, update an item over there. Talk about it for referential integrity. Or what if you change the last name in an employee table because someone gets married? Well, what if you change the last name there? Well, we need to also update it on a payroll table. So I can have a trigger that fires off. When you do an update on this table, also update this table and this table. So that's how they'd be helpful in referential integrity. We're going to execute this. I didn't get my create trigger after insert. Oh, that creates it. All right. And we're going to test it, and I don't have a command to test it. So let's see. We're going to do an update. So where's our update statement up here? This guy right here. We'll change this guy to square feet, just so we know we've changed it. And we'll execute this guy here. I still didn't get update production unit measure. Should have gotten just a baby little command. Oh, I did an insert. Okay, we need to do an insert. That was an update. Let's do this. So we're going to change this trigger instead of after insert. I did this on purpose so you know what we could do. We're going to change this to update instead. And then we're going to go up, change this to square footage.
That's not how you spell that.
Footage. Feet footage.
Feet-footage is cool,
Feet-footage.
but I don't think that's what you meant.
Square footage. Now we'll do one more update on this baby right here. Execute. Is that name equals square footage? Where? Near F2. Did I not grab that last quote? Maybe I didn't. Let me see. Yeah, probably didn't. Well, I still need to get my trigger though. Oh, the trigger was already created on. Oh, okay. So you know what went wrong there is I had a trigger created for insert. That's already on the table. All I did is try to change this. I created another trigger for update, which probably failed because there's already one out there. Should have gotten an error on that. So all this would have done is down here instead of one row affected, it would have said unit measure successfully added. It's not pretty, but it's a way to let you know. A better way for using triggers in the real world for referential integrity, I make an update on the last name column in the employee table. It needs to be updated in 3 other tables. That trigger fires and it updates it in accounts payable, and everywhere else that last name needs to be updated. All right, cool module on select statements and working with select statements and all the cool things for slicing and dicing the content. We went through all that with you. We talked about the different arguments, the between, the not. We saw all of these in action except for join. Just want to introduce those to you. And then we talked about DML commands, insert, bulk insert, update, delete. We saw all these in action. We looked a little bit at the clustered index and the non-clustered index, nothing to be too concerned about in the unique index. And then we talked about the use of triggers and how triggers can be used for enforcing referential integrity. If I make a change in one table, it can go out and update changes in another table. In our next section, we are going to talk about the fundamentals of database management, more of a, if you're a DBA, we're going to talk about securing objects. We're also going to talk about backing up and restoring content, because that's one of the big tasks that you'll perform as a database administrator.
Well, hello. We are at Module 5 of
Already.
the Database Fundamentals course on MicrosoftVirtualAcademy.com. Wow. So if you've been with us for the first 4 modules already, we started back with core concepts of what a database is and why they're important. We went on from there to a second module that was about
Normalization, all that conceptual
and
stuff that you have to
referential
walk
integrity,
through.
kind of a little bit of design fundamentals.
Yeah, yeah.
Then in Module 3 we did how we actually create databases and the objects that live inside of them. And then we just got out of Module 4 where we learned all kinds of things about using data manipulation language to get data out. And then we talked about insert, update, and delete to manipulate the data that's in a database, which is a lot of information to cover in just these 4 modules. But in Module 5, we're going to just wrap the course with a little bit of information about how to do basic administration. And this is very specific to SQL Server, which we've been using as the example database management system for the course. And you're going to help us understand kind of a little bit of security fundamentals and some data management backing up and restore type functionality for keeping our database administered nicely.
Nicely. Yeah, that's a good way to put it. Exactly what we're going to do is, one of the things that we've talked about is how much data we can store inside a SQL Server, how we want to design that data, and how to add the data and retrieve the data. But now we need to protect that data. So we're going to look at how SQL Server implements a security infrastructure. And the other piece that we're going to look at in this module is making sure that that database, the data is backed up regularly. In the event that something happens, you need to recover that data. So we're going to give it the basics on doing backups and restores. So securing the data and then backing up and restoring that data in the event that you need to do so. So we're going to talk about that in this module. We're going to begin with SQL Server security. Really, when you look at that, there's 3 components of security. We have what are called securables, which is the server, the database, and any object, the stored procedures and the tables and the views that we looked at. We also use the term principals. The principals are the individuals or the groups, whether it be Windows groups or individuals logging into SQL Server that are granted access to SQL Server. And then the last piece are permissions. What type of permissions are we going to give someone to access the content stored in a table or stored in a view? So it's the securables, the principals, and the permissions. And this graphic here shows you kind of a high level of how that works. You've got the principals over on the left-hand side, and you have Windows level security, because you can have 2 types of security. You can have Windows authentication, or you can have what's called mixed mode, which is a combination of Windows authentication and SQL Server logons. So at the Windows level, we can actually use a Windows group, a domain login, or a local login. At the SQL Server level, we have fixed or user-defined server roles. We'll introduce those. We have a SQL Server login. So first off, you have to log into SQL Server before you can access the database, before you can access objects in the database. So it's kind of a 3-tiered approach that we're using here. At the database level, we have fixed database roles. Not server roles anymore, but database roles. We also have user-defined database roles that we can create. We're going to talk to those. And then once you get inside of the database, you've got these items, tables, views, functions, procedures, different information that we want to protect. So to me, I always like to introduce this as a 3-tiered approach. Give the individuals access to SQL Server. Give them access to the databases, because they don't need to get access to every database. Give them access to the databases that require access that contain objects they require access to. And then give them access to the particular objects. And I can give them different types of access. I can give them just the ability to query information from a table or to be able to update information in a table, as an example. So the 3 tiers are accessing SQL, accessing the database, and accessing the objects within those databases. And we talked about the different terms available for us, the permissions, the securables, and the principals for doing so. Here's our 3-tier approach. We need to log in. It could be a SQL Server login, or it could be a pass-through login using Windows authentication to get access to SQL Server. We then need to give you a user account in the database that you need access to. And lastly, we need to apply permissions to the user account, which, oh, by the way, is mapped to the login. That's at the SQL Server level. So we have our SQL Server login. We can map a database user to that login in every database that you need access to. And then we decide within that database what permissions that you are going to get access, or what objects you're going to get access to, and what permissions you have with those with that object. We have a couple different types of authentication. We have Windows authentication or pass-through authentication. So it takes your credentials that you use when you're logged into the domain, and it uses those to authenticate you and give you permissions to log into SQL Server. We also have a group. You could be in a Windows security group. And that security group, if you're a member of that security group, if that security group has been granted permissions, you're going to have access for that. And so that's Windows authentication. We have what's called mixed mode, which is a combination of Windows and SQL logins. So if you don't have a Windows authentication, a way to log in, we can create a login for you inside of SQL Server. This is great for individuals like vendors that are external to the organization that don't get authenticated by an Active Directory environment or Windows environment, so we have to give them a SQL login. And what we can do with these logins is we use these logins to map them to either the server roles, fixed or user-defined, or the database roles, fixed or user-defined. And that's what's going to decide what permissions you get inside of the database that you get access to. Now, by default, SQL Server provides several different fixed server roles to define. A few of the key ones are sysadmin. You get full party rights to do whatever you want. You can uninstall SQL Server. So you've got to be really, really careful about giving that one out. The DB Creator allows you to manage databases. So I can create a database and manage that entire database. That's another fixed server role. Security Admin allows you to manage who gets access to SQL Server, who gets access to the logins, can manage the logins. So these three, just three of several that are out there, are available to you out of the box. SQL Server 2012 introduces user-defined server roles. These roles may not meet your needs for what you want your users to do. So you can actually create user-defined server roles that have special permissions depending on what you want the users to be able to perform once they connect to SQL Server. What you do is when you create the login, you identify what roles you want the individuals to be in, and that's going to determine what permissions they get. So you have your fixed database roles, your fixed server roles, and then you also have your fixed database roles. And within that, that's where we start talking about, so we've talked a little bit about connecting to SQL Server using a login from Windows or SQL, but we also look at securing SQL Server databases and the objects within those databases. And as I've just briefly mentioned, once we get access to Tier 1, which is the SQL Server level, Tier 2 is access to the database level, or whatever principal you want them to be able to access. I can map any of my logins, whether it be a SQL login or a Windows login, to different databases, depending on what they need access to. Once I give them access to the database, I can define what roles, whether they be user-defined or fixed database roles. I can define which roles I want them to be able to apply to. And there's a special role that's out there. People always see it, so I want to bring it up. If you happen to manage permissions, there's a special role called public. You can't delete it, you can't modify it, you can't move people in and out of it. It's just there. And so what happens if I happen to attach or try to connect to a database, it automatically, once I get permissions to that, it automatically allows me, populates me into that public role. So no management. It's actually used if you want to connect to a database, and let's say you want to print something. It kind of gives you some of the default permissions you would have or want inside of a SQL Server. The fixed database roles, just a few of these to mention. These are the fixed ones. DB owner, which means within that database. Remember, we had DB creator. That was at the server level. They can do anything they want. They have full party rights. DB owner has full party rights for that one database. So if I'm DB owner for sales database and Pete's DB owner for the Adventure Works database, I can't do anything in his database. He can't do anything in my database unless he gives me permission. So you're DB owner for a specific database or specific databases that you have permissions to. Another popular role for the fixed database roles is a DB data reader. So anyone who's in that role can read any data inside that database. So it's kind of like granting read access to everything in the database. And another one is DB data writer for individuals who actually want to be able to perform those inserts and updates and deletes that we walked through in the previous module. So those are available to us as a few of the fixed database roles. Similar to fixed server roles, we can create user-defined database roles. It is highly recommended for us to create fixed or user-defined server roles and user-defined database roles, because it gives us a more granular, a way to provide more granular permissions to our users. We have more control over what our users are getting for permissions if we use our user-defined roles versus the out-of-the-box fixed database roles or server roles. So either way, however you decide to do it, use these roles, whether it be the user-defined or fixed roles, to provide permissions to the users inside of SQL Server. Let's just jump out real briefly here, and we're going to jump back into our SQL management here. And so remember that first tier I said we need to get into security. So we've been talking about databases primarily. In here under security, we have a thing called logins. The logins is where you want to be able to map our users to give them access to SQL Server. It's pretty straightforward. Of course, there's transact SQL statements for this, but we're going to do the Windows way because we don't get paid by the hour. So we're going to go create a new login called Contoso Linda, and then we're going to go at default database they're going to map to. Get my mouse back. Disappeared on me. I don't know what screen it's on. Is it on yours over there? Oh, here it is. Really, I do have a mouse in here. There it is. Okay. So I'm going to say they map, when this person logs in, Linda logs in, she maps to AdventureWorks 2012. I can actually go up to the fixed server roles. These are the ones that I introduced to you already. I'm going to trust that she can take care of security, so I'm going to make her part of security admin here. All right. Now, I could also go into the user mappings here at this point. And here I'm going to say I'm going to give her access, because although I said I want her default database to be AdventureWorks, I've not even given her access to do that yet. So what I need to do is check this box and say for AdventureWorks, Linda has permissions to access. That's that second tier that we're providing. And then I'm going to make her DB owner. It picked out the fact that she had security admin. By default, it added DB owner for a fixed database role. I could change that to just be a DB data reader if I wanted to. So when you create the login, which is mapping your Windows, in this case here, mapping your Windows authentication login to SQL Server, it provides you the capability to also at that point decide what databases she's going to get access to. I can even go down to securables here, and here I can actually search inside databases and assign permissions at this point. I'm going to do that a little bit separately. I just wanted to show you at this point here, what I can do is, first off, map her account, her Windows account to SQL Server, gives her that first tier access. Secondly, and assign what server role permissions she gets. Thirdly, assign what database she gets access to. So I can go ahead and do that, and I'll just go ahead and click OK on that. And I'm going to get that a failed. Now column's name is missing or entered for select into statements. Let's see here. So maybe I probably need to do this. Let me try that one. No, great failed for login. So we're going to already exist. Okay, so let's see if that's true. Let me go over to AdventureWorks. The users are stored over under security over here. Users. Oh, she is already there. All right, so we're going to toast that right here. We're going to delete it. And OK. All right, now let's go back and try that again. So it was yelling because I was trying to add her to AdventureWorks as a user, and she was already in there as a user. So let's go back to our login box, see if it'll quit yelling at me. Try another OK. Still thinks it's there. Let me do a quick refresh. Refresh usually helps with this. Okay, I don't want to create a diagram, I promise. Let me refresh this. Let me go check security and users, not to be found anymore. All right, let me try one more time here. See if it'll add her this time here. If not, I'm going to switch to a different database if it yells this time. All right, so what I'm going to do is I'm going to give her access to our class demo database instead, being it still thinks she has access to that. Let me check everything I've done here. I'm going to go back up to general, Contoso Linda, server roles, security admin, user mapping. We'll give her access to class demo, and we'll just go ahead and click OK. Principal will already exist. All right, so maybe it's up even further. Maybe let's go back to here. Refresh. All right, let me delete it from here. All right, let me try this one more time. It seemed to see her in security logins already. So let's try this one more time here. So let's check again. Contoso Linda, server roles, security admin, class demo. Okay, that time it worked. For some reason, it still had her in login. So let me just refresh. Okay, she shows up there, and then we go to the class demo database that we created. We'll go into security there, and you'll see under users that she has access to there now. So using a quick, pretty easy and straightforward the interface where I can create an account, Windows account, map it to SQL Server, give her access to whatever server roles, whatever she's going to be able to do at the server level, which was security permissions, and then give her access to databases in whatever database and whatever permissions she'll have within those databases.
So we should just talk about what just happened
Sure.
in context of the rest of the course that we've been through. When we started out really simply with the CD library example, that might just be a single-use database. When we got up to something like Adventure, and in that case, you wouldn't necessarily need elaborate administration.
Right.
If you were in Access, you might grant it to one other user, but you might want to lock it down so that lots of people didn't have access to your library. In the case of the AdventureWorks, it's an enterprise class database with all kinds of different tables in there to manage different parts of the application. In that case, you want to think about the security model and the administration of the security to provide sort of the least privilege for the users so that people can't go get to any of the data that they may not have the business access to see. And that's kind of what's happening here with respect to the securities. You're thinking about the business use of the data, you're thinking about the users that are going to get into that data, and you're trying to create a security model that provides that sort of business rule for who can get into the data.
That's exactly right. So yeah, just to the event that you want to protect that data, you've got ways to protect that data. Like I said, if we're just worried about our albums, may not be too worried about that. But this is just more of a heads up as to what you're going to be, or you would be concerned about if this was in a bigger environment. That's exactly what we're doing. There's a guest account that's created in every database. How this is used is, if let's say I want to give everyone access to this database, it's going to be read-only database. I want to give everyone access to that. I can do that by just enabling the guest, giving them access to SQL Server, and they have access to the database to SQL Server. If I haven't specifically given them access to the database, it will allow them to come in as a guest. Now, by default, guest doesn't have anything for permissions, so you'd have to assign permissions to that guest account. It's enabled by default. You can disable it if you want to disable it using this command here, revoke connect from guest, and that will prevent people from being added into that. So if you're in a real high secure environment where you don't want anybody seeing anything unless you give them specific permissions, you want to be careful about that guest account because it is enabled by default and is available for use by default. If someone happens to create a login, didn't deny their permissions to a database, they do by default have permissions to whatever the guest account has in there. So they can at least connect to it and be able to establish that connection. Now we manage the permissions. This is supposed to be 3 lines here. We manage the permissions using 3 commands. And these commands here are grant. So I want to grant the select permission on a particular table to Pete. So I would do grant select on table XYZ to Pete. And then I could do revoke. So my revoke is going to reverse the last permission that I provided to an individual. The reason I'm saying that, why I jumped down to revoke and over deny, is because I could do an explicit deny to Pete on a particular table. And how I take that deny away is to revoke it. So it's the revoke is always going to reverse the last permission that you applied, either a grant or a deny. Now, why would I use a deny? A deny is available if I want to explicitly say that I don't want Pete in looking at this content. Now, Pete can come in through an individual account. He can log into SQL Server that way. But Pete's also a part of 5 Windows groups as well. If I do an explicit deny, it doesn't matter if he's part of 500 Windows groups. I've explicitly said, do not let this person into this database or look at this object. So you grant permissions, you apply permissions using grant. You revoke them. I put them with what I call in neutral mode. I haven't said you can touch it, but I haven't said you can't touch it by using deny. So you grant and then you revoke, or you deny and then you revoke. So you reuse these terms or these statements to manage our permissions in SQL Server, specifically at the object level. Now, what I can apply for permissions, I can grant select for Pete, so he can come in and view content. I could grant select and insert, so you can view content and add content. I could grant select and delete. He can grant and delete content. So I can be very granular as to what permissions the individual or the group can have on a particular object inside a SQL Server. And we're talking about the DRI, data referential integrity. That's the reference when we use that for the foreign key back to the primary key we talked about earlier. And the execute is for executing store procedures. That's a short term for that is EXEC instead. So those are different types of permissions that we can apply to tables or stored procedures or views. Depending on the type of object, we'll determine the type of permission that we apply to those objects. But they're managed using the grant, the deny, and the revoke. Is that enough, you think, to
I think that's great.
explain?
And this is another, we've said this several times during the course, this is another opportunity for a lot more further study. We have an entire course just on database administration that goes in depth on sort of the theory for database security, as well as all of the implementation details for how you set it up.
Yeah, I think the thing we wanted to do is just make sure you're comfortable with the idea that, we're not just because you created these database and tables, you do have to be aware of the fact we can lock these down, we can secure them. Not worried about it if it's just our artist collection, but if we're in more of an enterprise level or bigger environment where we are concerned about security, there are ways using what I call a three-tiered approach to SQL, to the database, to the objects that we can control what your users get access to. So just more of a high-level overview. Now, one of the other things that we have to be concerned with is protecting our data, because as if you are a DBA or aspiring to be a DBA, one of the probably the biggest things that you're responsible for is protecting the data and making sure it's available in the event you have a power failure, you lose a disk drive, any possible situation where you might lose data. So what we're going to just do is briefly introduce, just so you have an idea, because often we get questions like, okay, Brian, I'm going to put all this data in there, and I'm going to store it in there, but what happens if I lose that data? Okay, what happens if I lose my Excel spreadsheet? Well, we have backup and restore capabilities inside of a SQL Server. We're going to use the GUI to keep it simple, but we can write scripts. We can script this all out, so that way we can run these at night. And the advantage of writing scripts, so the GUI I'm about to show you, again, if you get paid by the hour, you can set the alarm at 2 o'clock. You go up at 2 o'clock in the morning, you log in, and you perform a backup using the graphical user interface in SSMS. But if you don't get paid by the hour, you can write a script that performs the same task I'm about to perform and trigger it to kick off at a certain time, so it's running while you're sleeping or just getting home, depending on what you're doing in your nightlife. So let's go take a look at database backup. It's actually performed in the event that you need to restore that content. Somebody may accidentally delete some content, or we may accidentally, a hard drive may crash, and the content that I was on that hard drive gets lost. We need to be able to recover that content. So what we can do is use a database backup that will allow us to restore that content. Now we can only restore it depending on and we won't even get close to being able to explain all this, but we can only restore the content as good as the last backup. So if you do backups once a week and it's on Sunday night and you do have a system crash or you lose a hard drive on Friday, you've lost a week's worth of data. So there's a whole strategy in place on how many backups and how often and the different types of backups that you need to be aware of. And there's really just 3 key backups that can come up with a decent strategy for you. Those are full backup, where you back up everything regardless if it's changed. We could do a full backup every night if we wanted to. If I got 30 gigs of content, and if I do a full backup every night and it takes 3 hours, when only 10% of that content changed, maybe I don't want to do a full backup. Maybe I want to do a differential backup. Differential backup, I also call it a cumulative backup. It backs up the content that changed. So again, we did a full backup on Sunday. It backs up all the changes from Monday. I do a differential on Tuesday. It backs up the changes from Monday and from Tuesday. I do a differential on Wednesday. It's cumulative, that's why I'm saying that. Monday, Tuesday, and Wednesday are all backed up. The reason that we like doing differential backups is because when you get ready to restore content, we want to minimize the downtime. If I have one full database backup that I have to restore and one differential backup that I have to restore, it's going to shorten the time it takes me to recover, and that's going to be a good thing. So differential backup is a cumulative backup that keeps track of all the changes since the last time that we did a full backup. An incremental backup is also a transaction log. Those are used synonymously. So an incremental / transaction log backup. Let's go back to our scenario. Sunday night we did a full backup. Monday we did a transaction log backup, not a differential. Tuesday we did a transaction log backup. Wednesday we did a transaction log backup. Now if I lose content on Thursday, what do I have to do? I have to restore the full backup from Sunday, the transaction log from Monday, then the transaction log from Tuesday, then the transaction log from Wednesday. Could take me a lot longer to perform the restores of those transaction logs. So differentials are helpful. Some people do full backups, we'll say once a week. Differentials every night. Incrementals or transaction logs every hour during the day. Your strategy will depend. The bottom line is you always have to answer the question, how much data can you afford to lose? If the answer is none, you need to be very particular about what type of backups that you perform so you can recover that content in the event that you need to. Just to let you know, these are the three primary backup types that you need to be familiar with. There are others that we're not going to get into detail. So if you're looking around at this because you're going to be excited about SQL Server when we finish today, if you're looking around at this, there are other types of backups that you can perform. Take a peek at those, but these are the three primary ones that you'll be using here. So let's go ahead and back up a database just to show you how easy it is to do this, because we're going to use the GUI. And back in the SQL Management Studio, let's back up. Let me see. Let's in class demo. Class demo, nothing. Let's go. I thought we created a table in there. Did we not over there? Well, we created that one in sales. Let's go and create. Let's do this. Let's do a new table in class demo. Thought I clicked that. So I showed you how to create a table using Transact SQL. You can also create a table inside the GUI. It will happen. So we're going to call this column 1, real definitive as to what it is. Here's my data type. The default is nchar10, and we allow no's.
I thought for sure you were going to start creating the CD library database.
Artist. We'll do the artist.
You're going to do the artist table. Interesting.
Yeah, we'll do the artist one, yeah. I know I didn't want to get over to, I keep losing my mouse. I didn't want to get over to the disco one, you know, the genre. So artist, what we have, well, we would have artist ID actually.
Artist ID and probably artist name, maybe.
Yeah, artist name would be good.
Probably a picture.
No, artist name, I need to do, notice I'm going to use that Pascal.
Birthday.
Birthday.
I'm going to keep giving you
Artist
columns
name.
until you stop. So
All right,
you
so
do as many as you want.
Let's change this, because now we found out these guys can be crazy with names. We need to bring this back to an int for artist ID.
Because that'll be your key. Look at us sort of reviewing everything we just did today.
Yeah, this is going to be our int there. And we're not going to allow nulls. And let's do one more here.
Birthday, maybe?
Birthday.
Because I'm sure that you and Donna Summer have the same birthday.
Yeah. Well, we went to different schools together, so. And once that'll give us a chance to use. I just have no idea why my mouse just disappears every once in a while. As soon as I get my mouse, oh, there it is. It just disappears.
It's jumping out of the VM. That's all right.
And we're going to go date.
But this is cool. This is a third data type in this table.
Yeah, so we have an int,
awesome.
and varchar, and a date. The bad thing is we're going to toast it anyways, but not really. But all right, so we have a new table here. So we're going to save this table out, and we're going to call this artist. And I think we should have done a genre so I could just type the word disco in. I mean, we talked about it all week, all day. All right, so we have a new table. So we'll come over here to our tables. We'll refresh it. We see our new table here. All right. Now the reason I did that is because I'm going to back this up. I'm going to go to Tasks, and I'm going to use the backup option. And it's going to back up class demo. And by default, it dumps it way down here. And, you know, we're going to get rid of that. I've got another easier directory to remember to chase it down afterwards. And we're going to back this up to, it's always, no, I won't even say it. I was going to make a joke, but if someone really doesn't understand, they might think I'm serious. And I'm like, no, I'll leave it alone. We're going to back up to SQL backups. And we're going to call this class demo DB. It'll use the .bak extension, so I'll just let that go. I'll let that go. There it comes back. So we're going to back it up to there, and we'll go ahead and do an OK. And then we'll click off on OK on this one. And the backup database class demo completed successfully. All right, cool. So that's done, and we know in there that we should have the dbo.artist. Now, there's a slide on restore, so I'm going to just stay in the demo, but Let's pretend that somehow this DBO artist gets toasted.
You've been waiting to toast something for the entire class.
I know,
I think
I
you should do. I think you should do that.
I know. I should have actually. What I should have done is prepare and written that
You
stored
could have written
procedure
a stored
called
procedure
toast.
called toast.
Yeah,
Exactly.
I'm gonna work
that
on that.
actually
I had
called
it
the
once.
T-SQL command for drop.
Yeah, I'm going to definitely write that. So I'm going to delete this. Now, this could be somebody accidentally deletes it, or they run that delete command I told you about without a where clause or an update. Maybe just the data is bad because someone ran an update without a where clause. And the faster way to get it back is to go do a backup. So I'm going to go ahead and toast this. And I'm going to do a refresh over here in class demo. You'll see under tables now, the table's gone.
Gone.
All right, toast. All right, so how do we cover it? Class demo, go back to task, and we have the restore option. And database, and we're just going to keep this the simple method. It knows what's been backed up. It's telling me right now, the only thing I have for you is a full backup. If there were differentials and incrementals, it would list them all out. It would make sure I restored in proper order. It wouldn't let me jump around and stuff because that'd be badness. So it knows we backed it up. Here's the date and the time for the backup, so we know it's good. And let's see here. I'm just going to leave it just at this. Attempt to restore. And during the restore here, it's actually what it's doing. It's actually looking at the information that's in the backup and determining exactly where that needs to go to do that restore. And looks like it's okay. Well, how can we test? We'll go back, see if our table's there. Let's do a refresh, because it's not showing up. Still not showing up. Sometimes the refresh has to go all the way to the top here. Let me do that one. Let's see, what am I doing this guy here? Still not there. All right, let's try another restore, because that didn't seem to pick it up. So I did the backup. I toasted it. So it should be there. All right, let me try it one more time. All right, tasks, restore, database. You know what? It didn't come back up and say it was restored. It should come up and say it was restored. And I didn't see that pop-up box. So let me try this again. So we've got this check.
But the backup is still on disk, so it should be totally fine.
Right, correct.
Because it's listed right
Once
there.
this ends right here, it should say restore completed successfully. And I didn't see that last time. And it really shouldn't take that long because there's really no data in there.
I still think this might be a ploy. See if you can create the genres table.
Really? I really want to type in disk out. No, see, it's not. It's
Restore
database failed. All right, let's try this. Let's do the verified backup just real quick. So that's okay. All right, let me cancel this. Let me try one more time. Tasks, restore, database. And class demo DB is the database. Database there. Database. Full backup we just did. Let's see if there's any options. I'm not trying to move it.
Is this similar? Is there somebody connected to it? Is that problem?
It may be. Let me try this. Closing existing internet. This may be a single user. Let's try that, just in case it is. Because it should be a nice right there. That's what it was. Because I was still connected to it.
You were still connected to it.
Yeah.
I thought we were going to have to do some tap dancing or something to entertain the audience while that was happening.
Yeah, seriously. Let's see if it worked though. Let's go make sure it's over here. Yeah, there we go.
Got it.
Yeah, I was still connected to it. You're right. So it didn't get exclusive. It needed to be in single user mode. So I did that on purpose. So you guys can see it's not all peaches and cream to try to do a restore. There can be issues, even though it looks pretty straightforward. There's little things like connections that are out there already established. You need to make sure brings it during the restore. It brings it into certain mode, so it actually has exclusive rights to be able to do recovery.
Which is why there's a whole course that has like 3 modules on backup and restore, strategy and implementation.
Yeah, disaster recovery, and I mentioned the term earlier about RPEs, resume producing events. DR is going to be the most likely reason you have to generate a new resume because just not enough, the backups weren't done, or people were performing a backup and they didn't realize the backup wasn't working.
Which is actually pretty cool because we've gone from the very beginning of the day, we went from a spreadsheet, which you can have a backup strategy for. You can copy it to multiple locations. You can do cloud backup for a single file and things like that. We've gone all the way to, I need to take a class and just how to do like a strategy for creating incremental transactional backups for my enterprise class database.
Yeah. I mean, the backups is a class on backups, a class on data modeling or designing your database would be another one. Once you get the database designing out there, what's the best way? What kind of queries can I perform? How can I add content, update content to it? So all sorts of options that we've been through today and a high level overview, but just it's the real world for what it needs to happen. So we did so very similar to backups. We had the differential restore. We would perform those in order, and once we did those in order, that would make it easier for us to get that complete database backup, get the differential backup, and then get the transaction log backup restored. And I already did the restore because I was already out there. So objects that we need to secure, 3-tier approach. Giving them access to SQL Server, whether it be through Windows authentication or a SQL login if it's someone external to the SQL world. We introduced the 3 terms of secure roles, principals, and permissions. The second area was giving them permissions to the databases. We saw that. We can do that as we create the login. And the third one was giving them permissions to the objects using the grant, revoke, and deny permissions to manage those permissions. So login, database user, and then permissions to the objects are the ways that we're going to control our information or security permissions to our information. And with that said, Pete, I think, like you said, we started out with a basic old spreadsheet this morning, and now we've gone through is like how we can create a relational database with tables and enforce referential integrity by using primary key constraints and foreign key constraints. And we talked about how we can protect the data by implementing security, how we can use select statements for retrieving the content, and slicing and dicing it several different ways. Different ways for adding content, deleting content, and updating content. And then we wrapped up by talking about ways for securing that content and protecting that content by performing backups and restores. Is there anything you'd like to add?
I think we've nailed it. I think we covered everything we wanted.
And we still don't know what disco albums you had, so I'll find that out.
That will remain a mystery.
It
will
remain a mystery.
Follow me on Twitter and ask.
We did learn, though, that there was it 360 character title name out there, so that was going to totally redesign.
360 word.
No, it's 89 words, 360 characters.
89
yeah.
words, 360 characters.
So that totally redesigns our plan
so
for.
know your data, I think is the lesson.
Exactly.